So just really quick, remember to be timing yourself because you should be doing this entire exam in 1 hour and 23 minutes. And I know it's long, but this is really going to help you figure out which chapters you need to do and which ones you can skip. So I encourage you to do the entire thing if you have the book. So let's get started. So number 1 says the product of 1 minus 4i and its conjugate equals, so conjugate just means like this same thing, except the number in front of I, you change the sign. So if we're doing the product of this, we have to write that, and then the conjugate would just be 1 plus 4i. You just change that to a different sign. So this is 2 terms plus or minus and 2 terms plus or minus in parentheses, so we have to FOIL it, which is an acronym for that stands for what you need to multiply. So F stands for I multiply the first things, 1 times 1 is 1. O stands for I multiply the outer things, so 4i times 1, which is just 4i. I is for inside, so multiply negative 4i times 1, so negative 4i. And then L stands for multiplying the last things, negative 4i times positive 4i, which is going to be negative 16i squared. Now you need to remember that I squared is the same thing as saying negative 1. So this would be negative 16 times negative 1 for I squared, which is just going to be positive 16. And you can combine these like terms right here of 4i minus 4i, and those just cancel each other out. So then it's just 1 plus 16, which equals 17e. So now let's go to number 2. So for number 2, it says we have this is just scientific notation. So basically what you do is you pair up the numbers and divide them, and then you pair up the tens with the exponents and you use quotient rule. So you're going to do 2.16 divided by 3, and that's going to be 0.72 times 10 to now use quotient rule, which says if we divide with like bases, we have to subtract the powers. So negative 22 minus 11 is going to be negative 33. Now you might notice that these are all in scientific notation. This looks a little bit different. It's because it's not in scientific notation yet, because you have to have one digit between 1 and 9 before the decimal place in order for it to be scientific notation. So we have to move this over to follow that rule, but we can't just magically move that over and not compensate with the exponent. So because we moved it to the right by 1, this needs to go down by 1, so it's going to be negative 34 as the exponent. So it's going to be F. Thank you guys for liking the live. So then let's go to number 3. So it says for the line below, B is a point on AC. If AB is 20 inches and BC is 34 inches, then what is the distance between B and the midpoint of AC? So what we're going to do is we're going to say that we have AC right here, and then we're going to say that B is a point on AC, and then we're going to say, okay, AB is 20 inches, so this is going to be 20, and BC is going to be 34, so this is going to be 34 inches, and we want to know what's the distance between B and the midpoint. This is not the midpoint. There's some point in the middle, but not B. There's some other midpoint. To figure out what that midpoint is, we need to add up 20 and 34 and then divide by 2 to find the halfway point between that, A and C. So then we're going to get 54 over 2, and then we're going to get that that's 27. So the midpoint is going to be like maybe somewhere over here. I mean, it's not exactly to scale, but 27. So B, if we look at where B is compared to where this midpoint is, that's going to be 7 away from each other. So it's going to be B. So then let's go to number 4. Simplify the expression right here. So whenever we have i's on the bottom like this, if it's like 1 plus or minus an I situation, you just have to basically multiply by the conjugate on top and bottom, which just means you change the sign in front of the I. So then this is just going to be times, instead of 1 plus 2i, 1 minus 2i. Over 1 minus 2i. So then on top, that's just 1 times something, so it stays the same, so it's 1 minus 2i over, and then we have to FOIL this, 1 plus 2i and 1 minus 2i. So when we FOIL, it's going to become 1, and then minus 2i, plus 2i, and then minus 4i squared. Now these are going to cancel out on bottom, and remember, I squared is the same thing as saying -1. That's just something you memorize. So you can replace that with a -1, so then it becomes -4 times -1, which is just +4. So then you have 1 plus 4, and then 1 minus 2i on the top. So then this is going to become 1 minus 2i over 5. So it's going to be f. Basically, whenever, for the people saying that they're lost, whenever you see something with like plus or minus I on the bottom, all you have to do is multiply by the opposite of the sign in front of I. So you just multiply, instead of plus 2i, it's just minus 2i is how you do these problems. So, and these are very rare on the exam, so if you don't get this, then don't worry too much about it. That's one of the more rare topics. So then let's go to number 5 for a geometric sequence. A3, meaning like the third number in your list, in your sequence, is going to be 27 over 2. And then A6 is equal to 729 over 128. What is the value of A12? So we're trying to find out what A12 is. Now, it's a geometric sequence, so the formula for geometric sequence, this is for ACT, yes, for the person that asked, the formula for a geometric sequence looks like this, where n is like the number it is in the list, like it's the 12th term, n would be 12 if we're talking about the 12th number in a list of numbers. So what we're going to do is, if we're trying to find out what a of 12 is, we need to figure out what the first term in our list is, which we don't have, and we have to figure out what the common ratio is, which again we don't have, but we can figure that out from the information they already gave us. So they told us that we have the third number in a list. So if we were writing out our list, actually let me do it further down so I have more room. So we have, let's do 6 numbers in our list. Like we have a list of 6 numbers, right? So then they told us what the third number in the list, that's what that 3 means. It means it's like in place number 3 in your list, is 27 over 2. They told us that the 6th number in the list is 729 over 128. Now they told us that this is a geometric sequence. Geometric sequence means that you're multiplying by the same thing each time to get to the next number. So like to get to whatever's in the 4th term in the sequence, we have to multiply by something and multiply by that same thing again to get to the 5th number, and by that same thing again to get to the 6th number. Now that thing that we're multiplying is r in this equation, that common ratio. So we're multiplying by whatever r is over and over again. So what we can do is, I'm going to start with the 2 down here, and I'm going to see, okay, what do I multiply by 2 to get to 128? So if I do, let's think 2 times 2 times 2, that's not going to get me to 128. Let's try maybe 4. So then 2 times 4, that's 8 times 4, 32 times 4, yeah, that'll get me to 128. So then what we're going to do is know that the bottom number has to be 4. They're multiplying the bottom by 4 each time to get to 128. And then we're going to now go and see on top, what do they need to multiply by? That's going to be, hold on, let me check my calculator. I think it's, looks like 3 maybe. 27 times 3 times 3. And, why is it not letting me do that? And then times 3. Yeah, that works. Okay. So then it's going to be times 3 each time. So like times 3 times 3 times 3 gets you to 729. So they're multiplying by 3/4 every single time. So that's what r is. R is going to be 3/4. So we can plug that in up here for r. And we could say we already know that n is 12. So it's going to be that to the 12 minus 1. Now we need to figure out what the first term is, so we can use this information to go backwards. So like if every time you go to the right, you're multiplying by 3/4, that means if you go backwards, you're doing the opposite, dividing by 3/4. So we would divide by 3/4 and then divide by 3/4 again. So it would be 27 over 2 divided by 3/4. So then that's just going to be 27 over 2 times 4 over 3, because you have to keep change flip when you're dividing with fractions. We could cross cancel, so then that's going to be 18. So 18 goes here when you divide 27 over 2 by 3/4. Now we have to divide 18 by 3/4. So 18 divided by 3/4. We're doing this step because we need to know what the first term is to plug it into this equation to find the 12th one. So then we're going to keep change flip again. So keep this, change division to multiplication, and flip this to 4 over 3. And you could cross cancel. 3 goes into 3 once, it goes into 18 6 times, and that becomes 24. So that means that this number, A1, has to be 24. So now we can plug that in here. And now we have enough to figure out what the 12th term in our list is, because we have everything that we need to plug into the formula. So A of 12 is going to be equal to whatever 24 times 3/4 to 12 minus 1 is 11. So then, let's see, oh, actually, we don't even need to like multiply this all out. It looks like that they just changed it here. Hold on. So we're writing things in terms of 2s and 3s, it looks like, from the answer choices. So I have to think, how do I rewrite this in terms of 2s and 3s? Well, this is already a 3 up there. Now I have to think, okay, how can I turn the 24 and the 4 into something written in terms of like a 2 and a 3 and or a 3? Well, the 4 is easy. That's just 2 squared. Like 2 squared is the same thing as 4. So that's how I can write it in terms of a 2. And I'm doing that because I'm using the answer choices to help me. And I'm not going to waste time multiplying everything out when they put it in this format. So I'm trying to make it look like something in the answer choices. Now, when I do 24, I can think, okay, what are some factors of 24 that can help me? Well, 24 can be 8 times 3. And then that gives me a 3. And then 8 is just 2 cubed. Is the same thing as that. So now I have everything written in terms of 2s and 3s. So I can use all of my exponent or power rules to figure out which of these is equal to one of these answer choices. So I'm going to go over here because I'm running out of room. So I'm going to first do the power to a power rule. So this is technically 3 to the 1. We just don't write 1s as exponents in math for some reason. So if I do the power to the power rule there, that says I have to multiply the powers. So then I get 3 to the 11, because 1 times 11 is just 11, over 2 to the 22nd, because 2 times 11 is just 22. And then that's all being multiplied. I just copied down the other stuff here that I haven't changed yet, so it's just all being copied over. So now what I can do is I can just use my, the product rule with the 3's, and I could say this is 3 to the 1 times 3 to the 11, so I have to add the exponents. So 1 plus 11 is 12. And then that gives me that I still have 2 to the thirds over 2 to the 22. Now you can use the quotient rule here, and you could say, okay, I'm going to do 3 minus 22, and then that's going to be 2 to the negative 19, 3 to the 12th, and then you say, oh, I have to use negative power rule, which says that I put this on the bottom, 2 to the 19th, as a positive version. Or what you can do, which I think is like quicker and more efficient, is saying, oh, I have 3 different factors of 2 that cancel out on here, so I have to take 3 of them out of here on the bottom and just leave myself with 19 on the bottom. So then it's 3 to the 12th over 2 to the 19th. So like either way works, but it's just what works for you. So it's going to be D. And for the person that asked, are we timed? Yes, you are timed on the exam. Obviously, you would be going faster than this, but I'm trying to explain everything and teach everything. Let me just get water really quick. Okay, let me see if there's anything in my notes that I want to point out before I move on. No. Okay. So let's go to number 6. So it says, for the triangle below, which of the following is equal to 3 over 4? So, and it's talking about tangent and cotangent. So 3 over 4, that's this side over this side. So if we're looking at C, where do you find these practice questions? This is from the book that I wrote. It's coming out on Amazon in the next day or two. It's called Overcoming ACT Math. My SAT one is already out though. So then let's see. If you remember this acronym SOHCAHTOA, remember that this, if we're looking at angle C as our reference angle, because I'm trying to see what tan of C is from this one right here. Tan of C is the TOA part, which says that we're doing the opposite over the adjacent. So the opposite, 3 over the adjacent, which is 4. So that is equal to 3/4, which is what we're looking for. So that works. So if you were running out of time, you could just automatically cross out these, and you could still have a better shot of guessing just from doing that first part right there, because it has to be one of the other ones. But we're going to keep going. So let's go to cotangent of B. So B is this one right here, this angle over here. And when you learned all of like your trig identities, you learned that tangent and cotangent can be related by their complementary angles, meaning that angles that add up to 90. Since this is already 90 degrees and all the angles in a triangle add up to 180 degrees, that means that the other two angles have to add up to 90, because then it would be 90 plus 90 is 180. So these are complementary, meaning that they add up to 90. And we know the trig identity for complementary angles says that the tangent of like one of the complementary angles has to equal the cotangent of the other complementary angle. So tan of C has to also equal the cotangent of B, since it's the complementary angle. So that works out. And then cotangent of 90 minus C, well, another way to say angle B is 90 minus C, because these add up to 90. So if you said B plus C equals 90, then we would say, okay, B is equal to 90 minus C if you subtract C from each side. So this is really just saying cotangent of B, which is the same thing that we've already said is equal to 3/4 up there. So it would be 1, 2, and 3. Thank you guys for liking and sharing the live. So then let's go to number 7. In the XY plane, F is at 2, 7, and which of the following are the coordinates of the image of F after reflecting F over the y-axis? Okay, so how I remember the reflections is like when you're going over the axis, it's the opposite one turns to the other sign. So like if you're reflecting over the y-axis, the x is the one that turns like either negative or positive, like the opposite of what you already have. So we have to turn this into -2, so it's just -2, 7, so it's going to be C. So then let's go to number 8 up here. Let me just get water really quick. Okay, it says, which of the following is equivalent to this right here? So what we're going to do is, like you can use the answer choices to help you, and I see that there's E involved, so it's probably going to be the L of n ones. So I'm going to take the ln of each side. So I'm basically saying I'm going to take the ln of this, x squared, like the left, and then the ln of the right stuff. Now, one of the, what do you call it? I guess like formulas that you memorize is that these cancel out when you do that. That L of n and E will cancel out to just give you 64 on the right. And then over here, you also, when you take like the ln or the log of something, the exponent comes out. So it becomes 2 ln of x. And then you would just get ln of x by itself by dividing by 2 on each side. So then 64 divided by 2 is just 32. So it would be that one, which would be F right there. So then let's go to number 9. So number 9 says, assume that the number of bees in a hive triples every 4 years. If the current number of bees is 15, then how many bees will be in the hive 16 years from now? So right now, currently we have 15. Now, the important part to remember here is that they're tripling every 4 years. So it's not that it's going to happen 16 times over the 16 years. It's going to happen actually just 4 times that they're tripling, because 16 has to be divided into groups of 4 years, because it triples every 4 years. So it's going to be times 3 4 different times, which is just 3 to the 4th power. So that's what you have to do, just 15 times 3 to the 4th power. And when you put that in your calculator, you're going to get that it's equal to A. Thank you for the likes and shares, guys. So let's keep going to number 10. The function, this right here, is translated 3 units to the left and 2 units up to form a new function. What is the equation for this new function? So I like to remember like the translation, like transformation stuff, as when you're going left and right, it's the opposite of what you would usually think, because like a number line, you think like to the left is negative, to the right is positive. So if I'm going 3 units to the left, I would typically think on a number line that's going negative, but it's the opposite of what I think. So I'm actually going to be going positive 3 plus 3. And then if you're going up and down, it's what your instinct would tell you. So like up would be positive, down would be negative. So if I'm going up by 2, it's plus 2. So the part next to the x, the -1, I have to add 3 to. So then that means that whatever's inside has to turn into x and then whatever 3 minus 1 is. So 3 minus 1 is just 2, so x plus 2 has to be in there. And then the outside number over here for the vertical shift is going to be 2 plus 4, which is just 6. So it has to be plus 6. So I'm looking for something with x plus 2 in there and plus 6 out here. So that would just be G right there. This is for ACT prep, but a lot of this will also help you with the SAT for the person that asked. So let's go to number 11. Given that n is any real number, which of the following is true? So with these, what you're going to do is you can test out different like scenarios. I call these plug-in scenario problems. So n just has to be a real number. So I'm going to plug in different numbers to like test it out. So like, let's say that we have, I don't know, what should we do? Let's do like 1, I guess. We could try 1 and 1 on each side. And then we could try the negative version is another thing that you could do. So we could say n is 1. So negative 3 times 1 is just negative 3. Less than or equal to the absolute value of, if it's going to be 1, it's going to be the absolute value of negative 3 times 1, which is also just negative 3. That is less than that, but let's also try it with like a negative number. So let's try it with negative 1. If n is negative 1, then we're going to have negative 3 times negative 1, which is going to be positive 3. And then it's going to say that that has to be less than or equal to, and then over here, it's going to be negative 3 times negative 1 is just positive 3. Absolute value would also just make it absolute value 3. That works. So it's probably going to be this one. You could try out other numbers too, but let's just show you why it's not going to be the other ones. So if we go to B, like let's test out, I don't know, let's just say 2. So negative of 2 squared is equal to negative 2 squared, because I'm just plugging in 2 for n to see if it works. And this is going to say, now this is where people get confused. This is saying the negative of whatever 2 squared is. So that's negative 4. So this is saying negative 4 is equal to, and this is different. This is saying negative 2 times negative 2, which is positive 4. That's not equal to each other, so that's why it can't be that one. And then for C, if let's just use the same number 2. So absolute value of 2 is equal to negative 2. That's not true, no, because absolute value makes anything positive, so no. And then D, let's say negative 2 less than 2. That works, but then let's try out another number. Remember, we want to try negatives and positives because usually they have different like properties associated with them. So we're going to say the negative of, now I'm going to plug in negative 2 for n. So negative of negative 2 is less than negative 2. Negative of a negative is a positive, so this is saying positive 2 is less than negative 2. That's not true, so it's not that one. And then E is saying n has to be greater than 0. 2 is greater than 0, but negative 2 is not greater than 0. That does not work, so it can't be E, so it's definitely A. So then let's go to, let me just move this all over out of the way really quick. Okay, so now we're at number 12. So it says, what is the value of all of this? So this is just absolute value practice, so I'm going to copy over the negative 2, and I'm going to simplify all this in parentheses. So this says, or in the absolute value bars, I mean, so 2 times negative 5 is negative 10. So this is the absolute value bar of negative 10 minus 9. Negative 10 minus 9 is going to be negative 19 in absolute value bars. So it's going to be plus the absolute value of negative 19. And then we're going to subtract whatever the absolute value of negative 3 is, which is just positive 3. Absolute value just means you turn the inside positive. So I'm going to take the absolute value of this one as well and copy over all the other numbers. So this is just positive 19. And then copy down the other numbers. So negative 2 plus 19 is going to be 17. 17 minus 3 is going to be 14. So the answer should be H right there. Okay, so now we're going to go on to number 13. It says, the sides of a certain acute triangle are measured in inches. The side lengths of the triangle measure 13 inches, 14 inches, and 15 inches. The measure of the largest angle in the triangle is equal to B. Which of the following equations could be used to solve for B? Now, this is the law of cosines formula in the answer choices. It looks like that's what they want you to do. Now, how I remember, you can remember it with like the 3 different law of cosine formulas if you want, like with the A, B, and C stuff. I just remember as like whatever the angle is has to be the angle that corresponds to whatever the side is out here. So like this is the, if this is big B, this has to be the angle that's across from it. Like let's say we have a triangle like this, and this is big B's angle. That means that this side is little b because it's the one that's directly across. And then the other 2 sides just have to be the other numbers in the formula, is how I remember that. So I can automatically cross out the sine stuff because I know this is law of cosines. And then I could say, okay, it has to match up, B has to match up with the side that's directly across from it. How do we know which side is directly across from it? Well, it said that B is the largest angle, and the corresponding sides have to match in magnitude with with the angle. So like the largest side will be across from the largest angle, the smallest side will be diagonal, like directly across from the smallest angle. So that means that the one that's across from the largest angle, B, has to be the largest side. So B has to be equal to 15. So it has to be this one because that's the only one that says that. So it would be A. So then let's go to number 14. It says, for the figure below, the angles are labeled in degrees. The measure of angle BHF is 36 degrees and FJC is a right angle. What is the measure of, how do you know it was cosine and not sine? Because this is one of the formulas you memorize for law of sines and cosines. So like these are all in the format of like the formula for cosine. So that's how I automatically knew right away that it couldn't be that one. So then number 14, for the figure below, the angles are labeled in degrees. The measure of BHF is 36 degrees and FJC is a right angle. What is the measure of angle DEA? So DEA means we're looking for this angle right here. This is our mystery angle that we want to solve for. Now, I see vertical angles right here. Vertical angles are going to be always equal to each other. So this is 36. And I know that there's a triangle right here. I know that this is 90 degrees because a right angle is 90 degrees. I know all the inside angles of a triangle add up to 180. So that means that 36, and I'll call this x right here, 36 plus 90 plus x are all inside of a triangle, so they have to equal 180 when I add them up. Well, when I do 36 plus 90, I'm going to get that's 126 plus x is equal to 180. Then I'm going to subtract 126 from each side so that I can get x by itself. So it's going to cancel out there. And then I'm going to get that x is equal to 54 degrees. So this right here is 54 degrees. Now remember, we're trying to solve for this question mark angle right here. So this question mark angle and this 54 degrees add up to a straight line right here, because this angle plus this angle make up the angles of that straight line. A straight line adds up to 180. So that means 54 plus that question mark angle that we're solving for has to equal 180 degrees. So all we have to do is subtract 54 from each side, and that's going to give us that the question mark angle is equal to 126 degrees, which is J. Let's go to number 15 now. So it says, given the sequence 5, 11, 17, yada, 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 it keeps going, what is the sum of the first 60 terms? Okay, so these are formulas that you need to know. So first let's determine what kind of sequence this is, because that tells us what formula we need. So I have to see, am I adding something each time or am I multiplying by something each time? Well, this looks like I'm just adding 6 each time, so that means it's an arithmetic sequence. So that's the one where you're adding by something every single time. So that means that I have to use the formulas that go with an arithmetic sequence. So what I'm going to do is I'm going to set up the sum of 60 terms. So S of n, in this case it would be n is 60, is equal to, and again, I'm just plugging this into the formula that I know for arithmetic sequence, like finding the sum. And then it's going to be times whatever a1 plus a to the 60. A 60, like the 60th term in the sequence is. So the problem is I know what the first term is, but I don't know what the 60th term is. Because I know the first term in my list is 5, so I can replace that with a 5 technically. But I don't know what a of 60 is. I have to figure that out. So, oh, can I write the formula for this? Yes, sorry. I just kind of skipped ahead. So S of n is equal to n over 2, and then a of 1 plus a of n. So that's the formula, and I'm just plugging it in with the 60 for n, and then we're plugging it in as we go with what we're finding for a of 60 right now. So now I'm going to find a of 60, and the formula for this one would just be a of n is equal to, and then you would say a1 plus, and then it would be d, which is like the number that you're adding each time. So plus d times, and then it's going to be n minus 1. So I'm going to just plug that into the formula. If I'm finding a 60, because I need that to solve the sum of 60, I'm going to say, okay, what's the first term in my list? It's 5. So a 60 is equal to 5 plus d, the number I'm adding each time is going to be 6. So plus 6 times 60 minus 1. So then this is equal to 5 plus 6 times 59. Okay, and then 5 plus 6 times 59 is going to equal 359. So that means that this a of 60 is equal to 359. We already know a of 1 is 5, so let's plug that all in and solve for what the sum of the first 60 terms is. And I can already go ahead and say that 60 divided by 2 is 30. A of 1, the first number in the list, is 5, plus I found that a of 60 was 359. So then I just have to do 30 times 359 plus 5, which is just going to be 364, times 30, which would just be equal to 10,920. So then it would be B right there. So let's go now to number 16. Okay, let me just get water really quick. Okay. So for number 16, it says, for the people asking if I can go back, this will all be posted onto YouTube, so you don't have to worry about that. So number 16 says, suppose x is equal to all this, which of the following is equivalent to log of x? So log of x is what we're supposed to find, so we're going to take the log of each side to get what log of x is equal to. So I'm going to take the log of all of this, log of the left, which is just log of x, is equal to taking the log of this entire side. Now, when you take the log or the ln of something, which is something that's kind of related to this, but in a different problem, but when you take the log of something, what you need to do is, if it has an exponent, it comes out to the front, is what one of our rules is with logs. So we're going to take that 7 out to the front, and then we're going to write the log of all of this stuff inside the parentheses. So the log of a to the 4th, c to the 3rd, over a plus b to the 6th power. That's supposed to be a b. And then now, one of our other rules with logarithms is that if you are taking the log of something with a fraction bar or division in between, because that's what a fraction bar is, then that's really just subtracting two separate logs of, it's the same thing as saying the log of a to the 4th, c to the 3rd, minus the log of all of this. If you have division in between, you can subtract the logs of each separately. So what we're going to do is we're going to rewrite it like that. So I'm going to say 7 times, and then I'm going to say the log of a to the 4th, c to the 3rd, minus the log of a plus b to the 6th. So now, remember, I'm trying to make it look like one of these answer choices. This part looks more like the answer choices right there, but this part does not look like that yet. So I have to think, how can I manipulate this further? Well, I know that if I'm multiplying in between, there's a similar rule where, just like how when we were dividing, we subtract the logs. When we're multiplying, you do the opposite. You add it. You can add logs together. So we can, and I didn't make this a little swirly L. So this is going to be log of x is equal to 7 times, and then this would be the log of a to the 4th plus the log of c to the 3rd, sorry. That's supposed to be a 3. C to the 3rd, and then I just copy down the rest, minus log of a plus b to the 6th. And then what we're going to do is now, again, we're looking a little bit closer to this, but we're not quite there yet. So again, we can say, okay, I'm going to take out the exponent in the front. So then it's going to be that I'm taking out the 4. So it's going to be 4 log a here plus 3 log c minus all this stuff right here. And now I just have to do distributive property, because now it's looking a lot more like that. It just looks like they distributed it to each of the terms here. So it's going to be that the log of x is equal to 7 times 4 is 28 log of a plus 21 log of c minus 7 log of a plus b to the 6th. Don't worry if you don't understand this stuff too much. It's every once in a while you get a log problem on the exam, and it's usually not this. It's usually the easier log problems. So just so you know. So let's see which of these says that. So that would be H. Yeah, right there. Okay, so then let's go to, how do I learn this, the basics of this? I would just pay attention for my log chapter that I'm going to do another day this next week probably. So then let's go to number 17. For the circle shown below, f of j, meaning this, is the diameter, and point G is located at the center of the circle. As labeled in the figure below, the measure of arc FH is 50, and the measure of arc JK is 135 degrees. Which of the following statements must be true? Okay, so, hold on, let me get water really quick. Okay, so this is saying FHJ, angle FHJ, this one right here, plus FJH, which would be this angle right here, have to equal 115. So let's try to see what each of these angles are equal to. So they told us that this FJ is the diameter. So that means that this has to be a right angle because it has to be equal to 90 degrees, because if this is the diameter, that means that this whole arc is like half the circle, which is 180 degrees. And this is equal to half of that. So that would be equal to 90 degrees. So this is 90 degrees plus angle FJH is this angle right here. Now, it's intercepting this arc right here with the 50, and it has to be half of that intercepted arc, so it has to be 25. So this would have to be 90 plus 25, so that's going to be equal to 115. Yes, that works. Now, arc FHK would be like this right here. So this is half of a circle, like this portion to right here. This is half of a circle, so it has to be 180 degrees for that arc. So it's 50 plus 130. 180 degrees plus the 135 there would give us the whole arc. So 50 plus 130 is 180. 180 plus 135, that does equal 315 degrees. So that's good. And then we're going to now check out answer choice or Roman numeral number 3. HFJ is going to be this angle right here, HFJ, and we have to see, is that equal to 260? Well, no, because remember it intercepts this arc 100, which is 130, and it has to be half of that. So this would have to be half of 130, which is definitely not 260. So it would not be that one. It's just number 1 and 2, D. So then let's go to number 18. What is the solution to the following inequality? When will you upload this practice on YouTube? I have to like download a bunch of the videos and stuff. It takes a while to upload it and stuff. Probably in like the next couple of days, I'll have it all up. So then let's go to number 18. What is the solution to the following inequality? So right here, it says that this absolute value of this has to be less than -3. Well, absolute value means that you make it, it's always going to be positive. So there's no way that this is going to be less than -3 because that has to be a negative number. So when something's not possible, it's no real solution. J. Okay, so let's keep going to, let me just move all this out of the way really quick. Okay. So then let's go to number 19. So it says Laura was calculating her monthly, I'm going to cry, it's so hard. Don't be too upset. This is the diagnostic test for the ACT math book. So I tried to pick some of the harder problems whenever I could think about it from the different chapters. Because if you can do the hardest problem, you're probably okay with skipping that chapter, which is the whole point of the diagnostic, telling you what chapters to do. So then let's go to number 19. It says Laura was calculating her monthly expenses. In order to correctly calculate her monthly expenses, she needs to add 7 to a specific number and then divide by 7. So let's call this specific number x. So this number is going to be x that we're talking about. Instead, Laura subtracted 6 and divided by 7, getting 84 for her monthly expenses. If she had correctly calculated her expenses, then what would her monthly expenses actually be in dollars? So let's start with this scenario, which says that she subtracted 6 from that number and divided by 7 and got 84. That's what this would be in an equation format. So if we can figure out what that original number is, we could plug that into the first scenario that she was supposed to do to figure out what she should have gotten instead. So we're going to multiply each side over here by 7, and then that's going to give us x minus 6 is equal to 588. And then we're going to add 6 to each side, and that's going to give us that x is equal to 594. But remember, we're not solving for x, we're solving for what she should have gotten. So we're going to plug x into the scenario she was supposed to do, which is adding 7 and then dividing by 6. So we have 594, we're supposed to add 7 and then divide by 6. So when we do that, we get 601 over 6, so it would be E. So let's go to number 20. Which of the following represents an equation for a circle with an area of 36 pi and a center of 0, -4? This is the ACT math for anyone that's asking. This is the diagnostic test from my book. So then and if I'm going too fast for you, you can slow this down on YouTube later, which is why I upload them onto YouTube. So then, which of the following represents an equation for a circle with an area of 36 pi and a center of 0, -4? So the area is equal to 36 pi. We know that area of a circle is equal to pi r squared. So from this formula, we can figure out what the radius is, which is helpful because the formula for the equation of a circle looks like this. You see how it's equal to r squared. So if we can figure out what r squared is, we can eliminate most of these answer choices. So if I do 36 pi is equal to pi r squared, I can cancel out the pi's. 36 is equal to r squared. So that means that this has to equal to 36. So just from that, I can cancel out h, j, and k. So then what I can do now is this formula is saying that the h and k are the center of the circle. Like this is h and this is k. So that means I should be able to plug in 0 for h, and I should be able to plug in -4 for k, so it should be minus -4, which is just plus 4. So I should be looking for this, something like this, which is just going to be g. This is the pen, for people asking, the Papermate Inkjoy Gel 0.7. So then, let me just get water really quick. Okay, let's go here. If a cylinder's volume is 36 pi and its radius is 4, then what is the height of the cylinder? So the volume formula for a cylinder is that volume is equal to pi r squared times h. So if we know the volume, we can plug that in for V, volume, 36 pi, and then we can say that's equal to pi times r. They also told us what r is, the radius, so 4 squared times the height, and all we have to do is solve for height. So I can cross out the pi's on each side, so then I just have 36 is equal to 4 squared is 16 times h. So then I could divide by 16 on each side, so then it's just 36 divided by 16 is equal to what h is, and that would just be equal to 2.25 b. Okay, so now what we're going to do is we're going to go to, let's see, this is number 22, and we're using this graph to answer questions 22 through 27. Good job if you got that right. Hold on, my desk is getting really cramped. Hold on, let me just move stuff out of the way really quick. Okay, there we go, that's better. Okay, so we're on number 22. Okay, so what is the range of this graph? So range is the possible y's. So if we look at this graph, let's think what's the lowest y it goes to the highest. So the lowest it goes to, that looks like -1 right there. And the highest it goes to would be 5. So y can be between -1 and 5. So that's going to be k. And then let's now go to domain is just the opposite. It's the possible x values. So if you're familiar with the sine graph, it just keeps going forever and ever and ever and ever. So that's going to be all real values of x. Which the way we write that would be d. Now you don't use the little equal mark, like less than or equal to or greater than or equal to. You don't use that for when you're talking about all real numbers. Like with infinities, you have to use the regular less than sign. So then let's go to what is the amplitude for the graph. So the amplitude for the graph, you can get it from the equation or the graph. So I think it's easier to get it from the equation. So if you look at the equation, the amplitude is going to be like this number right here, but the absolute value of it. So like the absolute value of -3, like the number that's in front of the sign part that's being multiplied by it. So that would equal to 3. Now what you can also do is you could say from the graph, it would be, if you look at like the little bumps, the amplitude is basically like the distance from a bottom bump like this to a top bump, like how far that is, divided by 2. So like this bottom bump's at -1, the top bump is at 5, so the distance between that would be like 1 plus the 5 up here that you're traveling, because you have to travel 1 to get to 0 and then 5 more to go up, so that would be 6 divided by 2, so that would be 3. So that's how you can find it from the graph, and then from the equation is obviously easier. I would just do that. So then it would be J. So let's go now to number 25. What is the period of the graph? Okay, so this is again one of the things that you would remember with like your formulas and stuff typically. So this is in, if you have my book later on, know that you can like look this all up in chapter 44, just so you know. And what this is saying is the period is going to be equal to 2 pi over the absolute value of b. Now, what b is in this case would be 1, because it's like the number if there is 1 outside here. And there's technically a 1 there, it's just this is all being multiplied by 1. So this would be equal to 2 pi over 1, or just 2 pi. So that's the period for that one. So it would be E. And then what is the vertical shift? So the vertical shift, again, look at your equation to help you out. The vertical shift is going to be like the number that's away from all the sign stuff. So it's going to be this number right here. The 2, the number that's like floating on by itself, that's the vertical shift. So that would just be 2. This is ACT math, yes. And then for the phase shift, again, you can look at the graph, yes, if you prefer, but I think it's easiest to just think about it in terms of the formula for most people. So then what we're going to do for the phase shift is just, that's going to be the opposite of the number in front of x. So like, or not in front of, next to x. So this is negative pi over 2. The opposite of that would be pi over 2. So that's going to be your phase shift. So phase shift would be C, pi over 2. Okay, so let's look at this one right here. For the figure shown below, all side lengths are given in centimeters and all angles are right angles. What is the area of the figure in square centimeters? Okay, so this is like a weird shape that you basically have to break these up into regular shapes that you're used to. Like we could break this up into a bunch of different rectangles. So let's see, this is 2 plus 3 is 5. So that means that this portion right here has to be 5. And the rest of it has to add up to 10, so that means that this up here could be 5 as well. So we can break this up into a rectangle here with a length of 12 and a width of 5. So then 12 plus, or not plus, 12 times 5, length times width, gives you the area of this rectangle, just this piece right here, which is going to be equal to 60. And then we're going to now break this last portion up over here into regular rectangles that we can use. So we could say that this is going to be, let's see, what's the easiest way to break this up is probably going to be just like this, I would probably think. So then this would be 3 times 1, that's going to be 3. And then this is just, 1 is already over here, like this part is 1. So if we, what do we call it? If we subtract 1 from 5, this part has to be 4. So we know that this is 4 and this is 5 down here, so that's going to be 20. So it's going to be 60 plus 20 plus 3. We're basically adding the area of each of these pieces that we cut it up into. So that's going to be 83J. And let me just get some water really quick. Okay. Oh, and I haven't been checking if this is, I'm supposed to be editing also, just to make triple check sure that like all the answer key and stuff matches. So then let's see, number 29. So then this says that we have if x over y is equal to b and sine of x is equal to, I missed the j, yeah, sorry. and sine of x is equal to cosine y, then the value of x is equivalent to, okay, so let's see. Sine of x has to be equal to cosine of y, so that's going to be, what do you call it, the complementary angles thing. So x plus y must equal 90 for this to be true, because this is one of the trig identities is what they're called, where the sine of one angle is equal to the cosine of the complementary angle, like the other angle that makes it add up to 90. So that means that x plus y have to add up to 90. So we want to find out what the value of x is. So we're solving for x in this situation. So, and it looks like they want you to incorporate b right there. So we would have to solve for y over here, I think, and then just plug it in there and find out what x is after. So if I'm solving for y here, I would just subtract x from each side, so then I get y is equal to 90 minus x. And then now I can say, okay, instead of that y, I'm going to just plug in this, 90 minus x. So then it would be x over 90 minus x is equal to b. And then that would just be that, let's see, how could this work? Let's cross multiply and maybe I'll see it then. Okay, x is equal to b times 90 minus x. What am I not seeing? Is there another way to write x? Let's see. I'm losing my mind. Why am I not seeing it? Sometimes I just like blank out and don't see something. Wipe your lens, please. Okay, sorry. Hold on, let me just... Hopefully that helps. Hold on, let me get back into this. Okay. You know what, we might just skip this for now if I don't get it, like, right away, just so I can think on it, and then we'll come back. Sometimes I just need, like, a second to, like, trigger something in my brain. Okay, so let's go to, that was number 29, so now let's go to number 30. So then let's go to number 30. For the figure below, A, B, and C, D are parallel lines. So which of the following must be true for this one? Okay, so these are equal. So 1 and 3 are equal. So I'm going to just write that out, that 1 is the same thing as 3 because they're vertical angles. And I'm going to do the same thing for the 2 and the 4 because those are vertical angles as well. So everywhere that I see like a 2, I can replace it with a 4, and the same thing goes with the 1 and the 3. So, and for the person asking when you when you take the SATs or ACTs, you take them in junior year, and I'm going to come back to that problem. It's just like sometimes I just need to like take a step back and look at it again, and I just wasn't seeing that right away, so I don't want to waste time on the live, like just staring at it, but we'll go back to it in a second. So then we're going to go and say that angle, everywhere I see angle 1, I can replace with angle 3, and the same thing with 2 and 4. So let's see if each of these are correct. So let's see, 1 can be replaced with 3, is the same thing as 3, and 2 is the same thing as 4. So it's saying like the same thing, essentially, because 1 is the same thing as 1 is the same thing as 3, and 2 is the same thing as 4. So you're adding like the same things together on each side, essentially. So that would be true. And then angle 1 plus angle 2, and you could skip it on the test. You would just like mark it on your bubble sheet and then go back to it for the person that asked about like skipping it. So then angle 1 plus angle 2 is equal to angle 3 plus angle 4. So angle 1 plus angle 2, we would add those. Is that going to be equal to angle 3 plus angle 4? Yes, it's the same thing. So check that. And then angle 1, 2, 3, and 4, if we add them all up, do we get 360? Well, we know by corresponding angles that 1 is equal to like this angle right up here, because corresponding is like matching. So like the top left of this parallel line matches the top left of that one, so they're equal. Same thing goes with like 3 bottom right and bottom right of a parallel line are equal by corresponding angles. So then this all would be a circle. And so when all of these are a circle, that means like all the angles in a circle have to add up to 360 degrees. So then that's going to be true for number 3. So it's going to be 1, 2, and 3. Okay, so let's go back to, where did I put that paper for the previous problem? Where is it? Hold on. Where is it? I swear I just had it. Where did it go? Oh, it's right there. Okay. Sorry about that. Wait, yeah, this is the right one. Yeah, 29. Okay, so let's see. So, this one, okay, so we were right over here. Let me just take a second to look at it again, guys. Okay, so that's right. Those are complementary angles. And then we have x over y is equal to b. So then, let's see, x over y is equal to b. So then we could say x over b is also equal to y. And then we could say, oh wait, that might help us more. Hold on. I think that's how it is. Yeah. Hold on. Yeah, that would work because then you could say that you're going to, yeah, because you could plug it into this equation also. I was thinking of plugging it into that equation. I never even considered the other way around. So these are complementary angles because of what we know with trig, that like sine of something and cosine of like the complementary angles have to be equal to each other. So like angles that add up to 90 are complementary angles. So that's how I got x plus y is equal to 90. Now, if we rewrite this equation, we could say that x divided by b is equal to y, and we could plug it into this equation. I was just originally like starting here and plugging it into there, which doesn't work, but you could do it the other way around, and that's what's going to happen. Okay, so now instead of saying y, we're going to plug it in with x over b. So it's going to be x plus x over b is equal to 90. So then it's not written like that yet, but we're trying to solve for what x is. So what we're going to do is we could just multiply everything by b so that we have a common denominator. Or multiply, like, meaning like I'm multiplying the top and the bottom here because this is x over 1. So like x times b, x and 1 times b is what I mean. So it'd be plus x over b is equal to 90. So now I have a two fractions with a common denominator, so I can just add the numerators, bx plus x, and keep the like denominator of b, and that's equal to 90. So then remember, I'm trying to solve for what x is, so I could factor that out as the greatest common factor on top, and I could say that that's x. If I take it out, I leave b plus 1 in parentheses over b is equal to 90. Now I'm trying to solve for what x is, so I'm going to multiply each side by b, so then I have x times b plus 1 is equal to 90b. And then divide by b plus 1 on each side, so it's going to be 90b over b plus 1, which is c, right there. Okay, so then let me just move, stuff got messy right now, hold on. Let me move all this stuff that I don't need. Okay, there we go. So let's go to number 31, which says, a particularly annoying bird chirps once every 15 minutes. Samantha is trying to study for an upcoming exam and can't help but notice that the bird chirps 24 more times since it initially started chirping at 6 a.m. If this is true, what time is it now? So it's chirping once every 15 minutes. So that means if we're thinking in terms of hours, it's chirping 4 times an hour, 4 times per hour. That's times, not an x, by the way. So it's chirping 4 different times per hour. And then if it's been chirping 24 more times, to determine how many hours have passed, we're going to say there's 4 chirps in an hour. So we're going to divide by 4 and say that 6 hours have passed. So if it started chirping at 6 a.m. and 6 hours have passed, then 6 a.m. And then add 6 hours would be 12 p.m. So it would be D. Okay, so let's go to number 32 now. For a regular dodecagon, how large in degrees is the interior angle? Note all 12 sides are congruent. Thanks for liking and sharing the live, guys. So what you're going to do here, this is the, I forget what it's called, what the formula is called, but it's like where all the, where you can find out what all the inside angles, the interior angles of polygon formula, I think that's what it's called. It's the one that says 180 times the number of sides you have, n minus 2, that has to equal what all the angles inside of your polygon add up to. So we want to know not what all of the angles are, it's the sum of interior angles, that's what it is. We don't want to know what the sum of all the interior angles are, we want to know what each of those angles are. So if this is the sum of all of them, we have to divide by how many angles there are, which is 12, because that matches up with the number of sides. And then that's going to give us what they're asking for, one of the interior angles. Now, n in this case is the 12, because that's how many sides we have. So it'd be 180 times 12 minus 2 over 12. So then that's just 180 times 10 over 12. So then, again, you can use your calculator on this exam. So then that would just be 150 because you just plug that into the calculator. Let me just get water, guys, really quick. And let me check that my key is right. Yes. That was 32 is J. Yes, good. Okay. So then let's go to, this is for ACT math. So then let's go to 33 through 36. So this table is going to apply to the next couple questions. So what is the value of f of g of 0? So g of 0, we're going to start there. G of 0 means like what is g when x is 0? Because the inside the parentheses is the x. So what is g when x is 0? Well, that's going to be negative 2. So let's replace g of 0 with negative 2. So now we're asking ourselves, what is f when x is negative 2? Well, f when x is negative 2 is going to be 4. So that's going to be E right there. Now we're on 34. It says if f of k is equal to 6, then what is the value of g of k? So f of k is equal to 6. So that means that this whole thing is going to equal 6, which happens right here. And what's the x inside the parentheses, which they're labeling as k? It's the same thing. It's just meant to trick you. So what is the x when f is 6? Well, that would be negative 1. So that means that this is negative 1, the k part. So if we want to find g of k, we're finding g of negative 1. So what is g when x is negative 1? Well, that would be 3. So it would be j. Okay, so now let's go to, let me just check that against the key. Yes, that's good. Okay. Yay, it looks like I don't have to do any more really edits. Okay, so then let's go to number 39. Which of the following are, hold on, let me just adjust this so it's clearer. Which of the following are not true? So we're trying to find what is not true. And then we're going to be, oh, this is going to be annoying because I don't have the book portion. Okay, so we're going to be looking at this at the same time. Let's see, do I have, oh wait, I did this in the functions chapter earlier. So I can, hold on, let me get that out so we can look at it at the same time. Where is it? Give me 1 second, guys. There it is. Okay, so we can look at this at the same time as we look at the other thing so we don't have to keep flipping back and forth. Okay, let me just like fold it up. Okay, so here's the little chart thingy that we're looking at right there. So we're trying to see f of g of 3. So g of 3, g when x is 3 is going to be 1. So this is saying f of 1. And then so f of 1 is saying f when x is 1, which is just going to be 5. So this is saying 5 is equal to negative of whatever f of 0 plus g of 0 is. So f when x is 0 is going to be negative 3 plus g of 0, g when x is 0 is going to be negative 2. So this is saying 5 is equal to the negative of negative 3 plus negative 2 is negative 5. Negative of a negative is a positive. 5 equals 5. That's true. We're looking for what's not true, so it's not A. And yes, this is similar to SAT. Which of the following I'm like, when I go to the comments, I lose track. Okay, so B says f of negative 1 over g of 2. So f when x is negative 1. So f when x is negative 1 is going to be 6. So 6 over g of 2, g when x is 2 is going to be 6. So 6 over 6 is equal to the value of a when g of a is 4. So when does g equal 4? Well, that's going to be right here. And that happens when x is 1. X is what goes inside here, so it's the same thing as saying a. So a is 1. So this is equal to 1. That's true. We're looking for what's not true. So now let's go to C. So it says g of 2, which we already found out was 6 from the previous problem, minus f of 2. So f when x is 2 is going to be 7. Over negative 1 has to equal g when x is 3, which is going to be 1. So this would be negative 1 over negative 1, which is positive 1. That's true. We're looking for what's not true. So let's find f of g of negative 1. G of negative 1, g when x is negative 1, is going to be 3. So this is saying f of 3 is equal to 3 plus, and we just found g of negative 1 was 3, so 3 plus 3. Let's find out what f of 3 is. F when x is 3 is going to be 0. So this is saying that 0 is equal to 3 plus 3. That's not true. That's what we've been looking for, so it's D. Where can we see solution of the ACT when you finish for us to learn how to calculate? So this is from my book, and I upload all of the videos onto YouTube. So they'll be uploaded within the next couple of days. You can see it there. Which of the following statements must be true? So let's see. We have, again, okay, this is the same thing applying to the same, like, graph or table thing. So which of these must be true? This time we're looking for true. So when x is 1, so we're going to say x is 1. So f of 1, f when x is 1 is going to be 5. So 5 over 1 equals g of 2, g when x is 2 is 6, over 6. 5 does not equal 1 because that's what that simplifies to, so this is not true. So not that one. And then let's go to when x is equal to negative 2. So let's plug in negative 2 here. So g of negative 2 plus 3, negative 2 plus 3 is going to be just 1. So g of 1, they're saying, has to be equal to f of negative 2. So g, when x is equal to 1, is 4. So then 4 is equal to f when x is negative 2 is going to be equal to 5. Hold on, did I say that right? F of, oh sorry, it's f of negative 2. So 4 is g of 1. G of 1 is 4. F of negative 2 is going to be 4. Right there. So then that's equal to each other. So that's good. And then let's see, the third one says g of negative 1. So g, when x is negative 1, is going to be 3, is equal to the negative of what f is at 0. So f when x equals 0 is negative 3. So the negative of negative 3, which is just positive 3. 3 equals 3. That's good. So it should just be 2 and 3. J. I'm glad you guys are enjoying this. My YouTube name is the same as my TikTok, AG Tutoring. There's also a link in my profile. Let me just get water really quick, guys. Okay. So let's go to number 37. Let me move this out of the way now that we're done with that. Okay. Liam bought a motorcycle that was being sold for $4,800. Unfortunately, he didn't have enough money to purchase the motorcycle without taking out a loan. He was able to make a down payment of $1,200 and took a loan out for the rest of the amount. He repaid the loan in 24 payments of $175 each. How much more did he end up paying, including his down payment, by taking out this loan versus if he had paid for the motorcycle up front? So, paying for the motorcycle up front would be the $4,800. So he's paying more than that because he took out a loan. So the loan is going to be what he paid is going to be the down payment, $1,200, plus the loan payments, which is going to be 24 payments of $175. So this is how much he actually ends up paying, which when we multiply and add this all up is going to be $5,400. So then that's what he actually pays. This is what it would be if he just bought it all up front in cash or whatever. So then it would just be subtracting that amount to find out what the difference is. So that would just be $600. So that's A. What time you ended? Today I'm ending when I'm done with this this diagnostic test. So let's go to. I'm glad you guys are enjoying. So then, and remember, if you guys want to support what I do and stuff, please, if you have a Kindle Unlimited account, it's completely free to download my book and use it. And if you could rate it, that would be great because it just came out, so it doesn't have any reviews yet. So if you like it, please review it. And then let's go to number 38. What are the mean, median, mode, and range of the data set above? So the mean is just going to be adding all these numbers and dividing by how many numbers there are. Thank you guys for your support. So then what we're going to do is just add all these up to get the mean. It's already available for download on Kindle Unlimited. The SAT one is. The ACT one will be available in a couple of days. So it's just called Overcoming SAT Math by Sophia Garcia. And so now we're going to add all these up and divide by how many numbers we have. So in the list, there are 6 numbers. So we're going to divide by 6. So again, you have your calculator, so you can just add all those up and divide by 6 to get the mean. And that's going to give you that 2 is the mean. So that's the mean. Now to find the median, what you're going to do is you're going to line up your list from least to greatest. You could also do greatest to least, but I just have always been in the habit of doing least to greatest. So I'm going to do -5, and I like to cross them out so I don't like double write a number by accident. And then -2. Thank you guys for the support. And then we're going to go to 0, and the next number would be 4, and the next number would be 6, and then the last number would be 9. So median is like the median in a road, it's the middle. So it's going to be the middle number, or numbers in this case. When it happens to be 2 numbers in the middle, what you do is you have to add the numbers together and divide by 2. So the median would be 2. Thank you guys for your support. And then let's go to what's the next thing? Mode. Okay, mode is just the number that occurs the most frequently in the list. There's no number that occurs most frequently, so it's no mode. There's no mode. And then the range would be the highest number minus the lowest number. So it'd be 9 minus -5, which is just minus and minus is plus, so that's equal to 14 for the range. That's the range right there. Thanks for the likes, guys. And then let me move this out of the way. Oh, and I haven't checked this against the key. I'm supposed to be checking that just to make absolutely sure, like a third round of edits, that nothing is wrong. Yes, that's good. Okay. So let's go to 39. So 39 for functions, these functions right here, what is f of g of -3? So we're first going to find, I like to say work inside out, so I'm going to find g of -3 first. So g of -3, you see how -3 is in the place of where x is, so that just means you have to do the same thing for the rest of it. Everywhere you see an x, you have to replace it with -3. So it's going to be -3 cubed minus 1. That's going to be equal to -27 minus 1, which is equal to -28. So instead of writing g of -3, we can write -28. So it's going to be f of -28. And that's going to be equal to, again, this is replacing the x. So everywhere we see an x, we put -28. So it's going to be 5 times -28 plus 2. So then we're going to do 5 times -28 plus 2. And that's going to be equal to -138, which is just a. So let's go to number 40 right here. So it says, on a recent math quiz, Aisha had to determine the number of real solutions for the equation. This is the equation right here. She decided to solve this problem by using the discriminant formula. The discriminant formula is just the one that says b squared minus 4ac. Aisha's work is shown below. If she made an error, then what error did she make? So discriminant formula applies to quadratics once they've been set equal to 0. So we have to set this quadratic equal to 0. The way we do that is by subtracting 7 on each side first. So then that's going to cancel out on the right to make 0, and then we get x squared minus 4x minus 7 is equal to 0. Now we can figure out what b, a, and c are. So b is just the number that's being multiplied by x, so b is -4. A is the number being multiplied by x squared, which in this case is like a 1. We just don't write it in math. So a is 1. And then c is the number floating on by itself, which is -7. So I'm going to plug that into the discriminant formula up here. So I'm going to have -4 squared minus 4 times 1 times -7. So then I'm going to have -4 squared is 16, and then it's going to be minus 4 times 1 is just -4, and then -4 times -7 is going to be a positive 28. Oh, and actually we don't even have to solve for discriminant, it's just what the error is. I'm going ahead of it. So this is what she got, so what's her error? The difference is going to be this number right here, the 7, it has to be a -7, so let's see which one of those says that. She should have used a -7 instead of a 7. That's G. Right there. So then let's go to number 41. How tall is a pyramid when the area of the base of the pyramid is 60 square inches and the volume of the pyramid is 180 cubic inches? So the volume of a pyramid formula is going to be equal to volume is equal to 1/3 of length times width times height. So we know that the volume is 180, so we can replace V volume with 180, and then copy down the 1/3. Now, when you were learning about all these different shapes like pyramids and prisms and all of that, one of the things that you learned is with the pyramids, the area of the base, you could replace that. If you have that information, you could replace the length times width with that. So we have that information, so we can replace that right there with length times width would just be 60. And then we could say, okay, we're going to now solve for what h is. So this would be 180 is equal to 1/3 of 60 is 20, so 20h. Divide each side by 20, and that's going to be 9, so 9 inches, B. And for number 42, it says, Alan purchases a jacket from a discount store that always provides a 15% discount, and he has to pay an 8% sales tax. If the amount that the store charged Alan when he bought the jacket after applying the discount and tax is $89.25, then what equation could Alan use to figure out the original price of the jacket? So let's call the original price X. So initially he's going to, if we have the original price, we're talking about 100% of it, 100% of X. If we want a 15% discount, we're taking 15% off of 100. So we're talking about 85% of X is what we're paying after that discount. But then we have to pay the sales tax. So we're paying all of this, 100% of this new thing, this new price with the discount. So we're paying 100% of that plus the 8% sales tax. So we're paying 108% of this. The way we would write that as an equation would be J right here. So, because all you have to do to turn a percent to a decimal would be like move the decimal place 2 to the left, so 1.08 times, and 85% of X would just be 0.85 times X. So it would be J. Okay, so let's go to number 43 right here. So it says, oh, hold on, let me check this against the thing, just to make sure. I'm supposed to be doing like extra edits, just to make absolutely sure everything's good. I don't need to do anything for that. Okay, yep. So let's go and do this one now. So, let me get water too. Oh, shoot, I forgot something. Hold on. Forgot to take my meds. Okay, let's keep going. So, number 43, phone store sells family phone plans. They sell 3 different phone plans, A, B, and C. They order various phone models D, E, and F that come in the phone plans from a particular manufacturer. Each phone plan contains a different number of each of these phone models. The table below summarizes the cost of each phone model that the store pays to the manufacturer and the number of each model included in the phone plan. So, like, phone plan A, for instance, has like 2 of model D, 1 of model E, 3 of model F, and like you would do the same thing for like each of the other phone plans. And then like this is how much each of those phone models cost. So like D costs $120 for each of them. So now let's go to this problem, which says if the phone store plans to sell 2 A's, 3 B's, and 7 C's, then how much will it cost the store to order the necessary phone models from the manufacturer? So let's figure out what one of A is, like how much one of the A phone plans would be, and then multiply that by 2 and do the same thing with B and C, and then add it all up. So one of the A phone plans has 2 of the D models. So that's going to be 2, and actually you could just do it right here. It might even be easier to just do it all like right here, 2 times 120, because it's 120 for each of those. And then it would be 1 times 225. And then it would be 3 times 300. So then you would just add all those up to find out like how much is in one of the A phone plans. So then in one of the A phone plans, it's going to be that there's $1,365 that you spend. But then remember, it's set up here that they're doing 2 A's. So if we want 2 A's, that's going to be 2 times that. So that's going to be, if we do 2 times that, we're going to get $2,730. So 2A is $2,730. And then now we need to find what 3B is, 3 of the B's. So again, let's multiply by what each of them is. So like one of the D's, 1 times 120. 0 is just like, we don't need to do that. They're going to get 2 of the F's, which each cost $300, so 2 times 300. And then we're going to add those up. So that's going to be, when we add these up, 720 for B. And then remember, we want to find out what 3B is, so we have what 3B is. So we have to multiply that by 3. And then when we do that, we're going to get 2,160. And then now we're going to find out what 7C is. So let's find out what one of the C's costs and then multiply that by 7. So 2 of the D's is going to be 120. 2 of the E's is going to be 225. 1 of the F's is going to be 300. So then we're going to multiply all that and add it all up. And when we do that, we should get 6,930. So then, or sorry, that's going to be 900, and then when we 990, and then when we multiply by 7, it's going to equal 6,930. I skipped ahead. I got excited. Okay, so then we're going to have 6,930, and then we're going to add all of these up. So then when we add all of these up into our calculator, that's going to be 11,820, so E. So now let's go to number 44. Thanks for the likes, guys. So if this is all that, or I'm not even going to say that, then which of the following systems of equations could be used to solve for B and C? So this is just going to be like your power rules. So power to a power says that you can multiply these. So it would be like B times C. But the way that the power rules are helpful is when you have like bases, meaning like the big number is the same. So we have to think, how can we turn this to be like the same thing so it's more useful? Or you could say, if you already know like what number goes up here to equal 64, you could do that as well. So there's like 2 different ways that you can kind of like go about this. So I already know that 4 to the 3rd power is what equals 64 if like you've memorized your perfect squares and perfect cubes. So we know that BC has to equal 3 because we have to have 4 cubed is what equals 64. So I can cross out H, J, and K automatically. And then over here, this is the quotient rule, which says we already have like bases. So it says that we can subtract our powers. So we could say 3 to the C minus B is equal to 243. Now, with this one, you can say, okay, this one's a little bit harder because it's not going to be one of our perfect like squares or cube ones. So I would recommend rewriting this just to kind of see it visually better. So 3 minus CB, I'm going to think, okay, how can I turn this 243 into 3 to some power? So that's going to be 3 to the 5th power is what equals 243. And then so 3 to C minus B has to equal 3 to 5. So that means that these have to be equal for that to work. C minus B has to equal 5 for these to be truly equal. So that would be G right there. And then let me just check this. Good. No errors on the key. Awesome, awesome. Okay. So let's go to number 45. Okay. So number 45 says, for the figure shown below, triangle ADE, right here, is a right isosceles triangle. Sorry, I'm trying to get it to not be blurry. I don't know why it's being like blurry today. Right, triangle ADE is a right isosceles triangle. So isosceles means that 2 of the sides have to be the same. So if this is a right isosceles triangle, that means that the longest side is the hypotenuse over here. So this is the other leg that has to be the same. So I'm going to just label that right away. Point D is located on CE, okay, and CD is equal to 9, and DE is equal to 3. It's already labeled. What is the ratio of the area of ADE to ABCE? So we have to find out the area of this and then put it in a ratio to the area of the entire parallelogram. So the area of this triangle would just be half of base times height. Base and height are just the sides that make a right angle with each other, so 3 and 3. So half of 3 times 3 is going to be the area of ADE, and then we're putting it in a ratio to whatever the area of ABCE is. So ABCE is a parallelogram. Area of a parallelogram is base times height. So the height is 3. The base is this entire side that it makes the right angle with, so 3 plus 9. So it would just be 3 times 3 plus 9. So then we just have to solve this. So this would be 9 halves to 3 times 12. So that's just 9 halves to 36. Now, how I teach students to kind of like think of ratios, which I think is most helpful, is to think of it as like a fraction. So instead of writing like the ratio things, think of it as like the dots. Think of this as like, it could be the same thing as a fraction bar to kind of help you finish simplifying it. So how do we simplify fractions? How do we divide fractions? Well, we say 9 halves divided by 36 over 1 is the same thing as multiplying by the reciprocal. So it's equal to 9/2 times, keep, change, flip, keep the 9/2, change the division to multiplication. And then we're going to flip this to 1 over 36. And then we're going to multiply across, or you can do cross canceling to save yourself time. Like say 9 goes into 9 one time, 9 goes into 36 4 times. And then we just multiply across to get 1 over 8. And remember the fraction bar we can replace with the ratio dot things. So we can say this is 1 to 8, which would just be A. So now let's go to 46. So it says, what is the vertex for all of this right here? So vertex, one of the formulas that you can memorize is that the x min or max, because that's just another way of saying the vertex, like it's the min or maximum point, is equal to negative b over 2a. So just like we had b and a and c and stuff in the other discriminant formula problem, the b's and the a's are like representing the same thing here. It's just in this case, b is going to be 4 and a is going to be 2. So if I want to find the x value for the vertex, I'm going to say that it's negative 4 over 2 times 2. Negative 4 over 4, which is just negative 1. So I'm looking for a vertex with an x value of negative 1. The only possible answer would be F. So then, now if you didn't get lucky like that and negative 1 wasn't like the only x option, like let's say this one said negative 1, comma, negative 1, and you had to decide between f and g, then what you would do is just plug this into the equation to find out what the y is. So like you put negative 1 in there and solve for what y is, and then that should match up with the negative 7. So let's go to number 47. What are the roots for this? Another way you could say that is what are the zeros? Move that out of the way. What are the zeros for this? This quadratic right here, so we would set it equal to 0. Now, you would probably be thinking like, oh, can I solve this, like, can I factor this? Because that's what people like usually try first. Remember, look at the answer choices to like use to your advantage. You see that there's like a bunch of decimal options, so you probably can't factor this nicely. What you can do, though, is you can plug in like a negative 1.6 if you want in for x, and 1 and all of that to like see which of these could be your answer choices, because if you plug in, for instance, like 1 in here, and you get 0, then 1 should work. 1 should be part of the answer. So you could do that, or the way that you would solve this, like if this was free response or like without answer choices, would be to use the quadratic formula equation, because when you can't factor, you use quadratic formula to help you find out what the solution is. So quadratic formula is this guy right here. I'm glad you guys are enjoying the live. Remember, please, if you have a Kindle Unlimited membership, it costs nothing to download my book if you like it and to give it a review, because this is my book. This is the ACT one. The SAT one is the one that's already out. ACT will be coming out in a couple days. So then let's go to now label what B, A, and C are. So A is the number being multiplied by x squared. B is the number being multiplied by x. And C is the number just floating on by itself over here, negative 8. So we're going to plug this in. So it's going to be the negative of negative 3, which is just positive 3, plus or minus the square root of negative 3 squared minus 4 times A is 5 and C is negative 8 over 2 times 5. So now all we have to do is just simplify the stuff inside the parentheses, or not parentheses, what do you call it, inside the radical. And I'm just going to go ahead and do 2 times 5 is 10. So I'm going to now do negative 3 squared, that's just going to be positive 9, and then minus all of this, multiplied together, so that's going to give me the square root of 169, which is one of the perfect square things that we learned. So it's 3 plus or minus 13. You could also plug this into your calculator if you don't have that memorized. So this plus or minus means that we can plus 13 and get something, and we can minus 13 and get something else. There's 2 possible solutions. So let's start with plussing 13. So 3 plus 13 over 10. That's going to equal 16 over 10, which is just 1.6. And then the negative version, the minusing version, is going to be 3 minus 13 over 10. So then that's going to be 10 over 10, which is equal to 1. So it's 1.6 or 1. Oh, wait, hold on. That was supposed to be negative 10. Whoopsies. So negative 1. negative 3 minus 13 is negative 10. I forgot to carry over the negative. So it's going to be -1 or 1.6, so it's going to be B. How do we download the book? So the book's available on Kindle Unlimited. So let me show you what it looks like. The, what do you call it? The SAT one is available. The ACT one will be out in a couple of days. Oops. Oh, I don't want to show you what's on my Kindle bookshelf. Okay, never mind. I can't show you right now. But it's basically called Overcoming SAT Math by Sophia Garcia. Overcoming SAT Math on Kindle Unlimited. So you can do that, or you can buy it on Amazon. But if you have a Kindle Unlimited membership, which is like, I think $10 a month or something like that, and it gives you access to a bunch of free books, that it's free to download on that. So just Kindle Unlimited, and you can get a free 30-day trial of Kindle Unlimited too. Just Google like free 30-day Kindle Unlimited trial. And so yeah, and if you want to see, like, there's a link in my profile to like the book if you want to see like what the cover looks like to make sure you're getting the right thing. And then this ACT one will be out in a couple days. So then let's go to number 48. It says solve for x in the equation right here. So with this one, right away, I know that this is probably going to be like turning them both into 3's, because 9 is equal to 3 squared and 3 cubed is equal to 27. And when you turn things into like the same base, you can match up the exponents more easily. So it's probably going to be something like that. But let's start by looking at the radical right here, which is a square root. So the square root is the same thing as saying, like the square root of something is the same thing as saying we're taking it to the 1/2 exponent. So I'm going to do that, and I'm going to say that this is equal to 27 to the x plus 2, just copying that over. So now what I'm going to do is I'm going to rewrite the 27 and the 9 in terms of 3's as their bases. So 9 is the same thing as saying 3 squared, and then I'm going to multiply that by the power that's already up there and copy down everything else. 27 is the same as 3 cubed. So then that's going to be 3 times all of the stuff that's already up there. And then power to a power rule says that I can multiply the powers. 1/2 times 2 cancels out. So then I'm just left with 3 to the x plus 3 is equal to 3, 2. And I can multiply this to get, or do distributive property. Technically it's the same thing, but 3 times x plus 3 times 2 is 6. So this is saying 3 to the x plus 3 is equal to 3 to the 3x plus 6. For this to be true, that means that these exponents have to be equal. So x plus 3 has to equal 3x plus 6. So I'm going to subtract x from each side. That's going to give me 3 is equal to 2x plus 6. Then I'm going to subtract 6 from each side. That's going to give me -3 is equal to 2x. Then I'm going to divide by 2 to get x by itself, and that's going to give me -3/2 is equal to x. So that's going to be G. Okay, so let's go to number 50. For a particular integer, if it is divided by 9, then the remainder is 4. Which of the following could be the value of that integer? Okay, so x is this mystery integer that we have, and we're dividing it by 9. And then that's going to give us a remainder of 4. We have a remainder of 4. Which of the following could be the value of the integer? So I would just start testing out points. So like, or not points, but like numbers, I mean. So 4 divided by 9, that's not really going to give you a remainder of 4. So then we're going to go to 14 divided by 9. So, I mean, you could set it up too. You could do it in your head, but I'll like show you here just so you could see. So like 9 goes into 14 one time. So then if you subtract 9, you're going to be left with 5 as your remainder. That's not 4. And then now let's try it with dividing by 9, 21 divided by 9. So 9 goes into 21 2 times, because 2 times 9 is 18. So we subtract, we're left with a remainder of 3, not a remainder of 4. And then if we do 32 divided by 9, 9 goes into 32. That's going to be 3 times. 3 times 9 is 27. So that's going to subtract to get 4. You get a remainder of 4. So it's going to be J, 32. How many questions are set for the SAT? On the SAT, there's 2 different math sections, so it depends on which math section you're doing. I always forget if it's like 20. There's like one of the sections is 20. One of the things is like questions, and the timing for the minutes is like one of them's 20 and one of them's 25. I think it's 20 minutes and 25. No, that wouldn't work. No, it's 25 minutes. Or hold on. Trying to think, 25 minutes, 20, I think it's 25 minutes, 20 questions. I always flip it by accident. So 25 minutes for that one, and then the other one is 55 minutes. So then let's go to the next one. Oh, wait, and you were asking number of questions. It's 55 minutes. Sorry, I was thinking of the timing because I was trying to figure out. So it's 38 questions, and then for the second one, the one that's like the calculator portion, and then the non-calculator portion is going to be, I always flip this in my head no matter how many times I say it. The calculator portion is going to be the one that's 20 is it 20 questions or 25 questions? Either 20 or 25 questions. I always mix up which one's the time and which one's the number of questions. Sorry, but like around there. Okay, so then let's go to the answer to 50 is not correct. Hold on, let me see. Oh, did I do this wrong? Hold on. I'm getting off track. Hold on. I might be doing stuff too fast. Oh, wait, hold on. Yeah, sorry. I made a mistake. That's 5. Thank you for letting me know that. Okay, so then, yeah, that should be 5. Sorry. That was dumb. Okay, so 49 divided by 9. Okay, 49 divided by 9, so it must be that one. 49 divided by 9 is going to be, and I should have been, this is why I should be checking the key as I'm going, but I'm not. Whoopsies. So then this would be 5. It goes in 5 times, so then it's 45 minus, and that is 4. That's a remainder of 4, so it should be K. Sorry about that, guys. So then let's go to 51. Number 51, for a class project, a teacher decided to survey all 30 students in her class to find out how, I love how that's the one I got wrong out of everything. Okay, so then for a class project, a teacher decided to survey all 30 students in her class to find out how many siblings they had. The table below shows the results of her survey. Based on the table shown above, what is the expected value of the number of siblings that a student has in this classroom? So when you're finding like these expected value or expected whatever problems, they always use that word expected. Most of them are going to be like when there's percent involved, or you could also write it in like a probability or fraction format. Same sort of thing. You multiply this times the percent, but as a decimal. So it would be 0 times 20% as a decimal is 0.20. And then you're going to do the same thing for all of them and add it up. So you're saying like 20% of them have zero siblings, so it would be 0 times 0.20, and then 20% of them have 1 sibling, so it would be 1 times the 20% that have those, plus, and then the same thing going for each of the other ones. So it would be 2 times 0.10, plus, I'm going to just continue it down here, and then it's going to be 3 times 0.30, and then plus 4, you could write it without the 0 also, it's just people sometimes ask and get confused when I just randomly drop it without explaining, so that's why I'm writing it. So then it's going to be 4 times 0.20 for 20%. So then all you're going to do is just multiply these and add it up, and when you do, you should get that it's all going to add up to 2.1. C. Okay, let me just grab some water really quick. Okay, so let's go to number 52. For triangle F, GH below, JK, LM, and GH are all parallel, so basically like these lines are all parallel. The lengths labeled in the figure below are all in meters. What is the length of KM in meters? What is, oh my goodness, what is wrong with me? Okay, so what is the length of KM in meters? So we're trying to find out what this is equal to, so I'm going to put a little question mark there. So one of the tricks that I teach students for like the SAT and ACT, and it pretty much always works, like I can't think of a problem that I've done in like, I don't even know how long that this hasn't been the case, where when it's a triangle within a triangle, just assume that they're similar, or when they're telling you like parallel lines with triangles involved, almost always they're all similar triangles. It's like trying to test you on the similar triangles thing. So like you could prove it to yourself, you could do all the like corresponding angles and all that if you want to, but most of the time you can just like don't have to confirm that, like it's just going to be one of the similar triangle problems. So what we're going to do, but if you like want like a 1600 or 36, then like prove it to yourself, whatever. But what we're going to do here is we know that with similar triangles, we're going to have that the sides are proportional to each other, meaning like you multiply by the same thing each time, or you could set up a proportion to get from the small to the big triangles matching side. So for instance, I would label this as the big triangle. In this case, like this one right here, the FLM triangle, that's going to be your big triangle in this case, because you're not interested in like MH or like any of the part extending past that. So this is what I would call my big triangle, and the small triangle, this is what I would call my small triangle right there. So if I'm setting up a proportion with similar triangles, what I like to teach my students is to remember small to big matching equals small to big matching. And what I mean by that is like the small side matches the big side. That's what I mean by small to big matching. So for instance, 4 is the small side that matches the big side, FL right here, which is 4 plus 3, which is 7. So 4 is to 7 as, and then you would do the same thing with another set of matching sides. The small side would be 16, 2, and then it would be 16 plus, let's just call KM will be X. In this case, we'll say is X instead of question mark. So that's what I mean by small to big matching equals small to big matching. So now what you're going to do is you're going to cross multiply. Oh, that's what I did. Okay, so I'm going to keep this. Okay. 112 is equal to 4 times 16 plus X. Sorry, guys. My ADD meds are wearing off. Okay, so then 4 times 16 is going to be, what did I say that was? That was 64. So then it's 4 times X is going to be 4X. And then we're going to subtract 64 from each side. So sorry, we're going to go back. I'm going to edit that out of the video in YouTube so that it doesn't confuse people if you want to come back and watch it after. So we're going to do 112 minus 64. So let's see. I'm going to just use a calculator so I don't even mess this up because I don't trust my brain right now. So that's going to be 48 is equal to 4x. So 48 is equal to 4x. So 4 times what number equals 48? That's going to be G12. Okay. Someone said leave it. Yeah, but I want it to like not look super confusing for people. And like I can get like rambly and stuff when I like am off my meds and stuff. So so we're gonna go to 53. So Charlotte bought a new car that consumes as few as 1 gallon per hour and as many as 1.5 gallons per hour. If gas costs $4 per gallon, then what would the cost range be for running that car for 15 hours? Okay, so let's see. 1 gallon per hour for 15 hours would mean that there's going to be 15 gallons. Yeah, because 15, and then times the $4 per gallon. And then it's going to be that the other option, like on the other end of the spectrum, would be 1.5 times 15, and then times the $4. So then it would be 1.5 times the 15 times $4 is going to be 90. And then this is 60. So 60 and 90 are like the two ends of the spectrum that we're looking at. So automatically we can cross these off. And it says it can be as few as that or as many as that. So it can include these numbers. So X could be like in between, but it could also include the numbers of 60 and 90 because they said as few as or as many as. So it would be A. This is for ACT math, which a lot of people take their junior year, but it's not like one grade level. It's a bunch of, it's supposed to test you on like all the math you've learned so far. So then for number 54, it says the number 2080 has how many prime factors? So right away, I know 2 is a prime number, so that's going to be one of the factors. And then, so then if we divide that by 2, 2080 divided by 2, that would be 10,040. So we have one of the prime factors right here, 2. You could keep dividing by 2 as well, but it's going to be like when they're asking about like how many prime factors it has, you can't like just keep counting 2 over and over and over again. So like 2 only counts once basically, if that makes sense. So let's see, what else goes into 2005 would go into that because it ends in a 0. So like anything that ends in a 0 is divisible by 5 and 10. So then 5 times 10,040 divided by 5 is going to be 208. So we have a second prime number. Let's see, 208, what could that be divisible by? Let's we keep dividing it by 2 and see if it looks better. If I keep dividing by 2, divide by 2, 13. 13 works. 13 is one of the factors of that. So it would be also 13 goes into that. So it's going to be, there's 3 different prime numbers that are factors. So it's going to be 3G. Okay, so then let's see number 55. Let me put this back over here. So let's go to number 55. Which of the following is the solution for all of this? So 4x minus 12x, that's going to be negative 8x, less than negative 24. So if you divide by a negative number, we have to flip the inequality symbol. So we're going to flip this sign before we forget and divide each side by -8. So then it's going to be -24 divided by -8. Negative by a negative is a positive, so it's going to be 3. Oh, so someone wanted to see like how I did the factoring for that. Hold on. I was doing it in my calculator, but oh, let me actually make sure that I got this right. Let me check it against the key too, just because we are losing it as it gets later. So let's see. I did get that right. Okay. Just making sure because you were questioning. I was thinking maybe I got it wrong, but no, I didn't. Okay. So, what I was doing was I was breaking it down into factors. So like 2 times 1040 is going to be factors and 2 is a prime factor. We're looking for just prime factors. So then I kept breaking up 1040 into factors. So then 5 times 208 and 5 is a prime number. So then that's going to be another prime number. So I'm up to 2 prime numbers that are factors now. So then what I was doing with like the 208 was like in my calculator, I was saying, okay, I know 208 is divisible by 2. I can't count that again. So I'm going to keep dividing by 2 and then seeing if I see any, oops, I hate this calculator so much. So 208 divided by 2. And then I kept like dividing by 2. Until I saw, like, when I got to 26, I was like, oh, 13 times 2 is 26. So, like, I kept dividing by 2 until I saw another prime factor, which was 13. So then that's what I was doing in the calculator. So that's that one right there. So do I have a website? Yes, my website is linked in my bio. So then let's go to, so this one we already figured out. That was going to be A. Okay, so then, yeah, let me know if I skip over something, because I tend to do that when it's getting later in the day. So, yeah, just let me know in the comments if you ever want me to clarify something. So then let's go to 56. If p is an even integer and p is greater than 1, then p plus 1 cannot be. So p is an even integer. So integers are basically like think of it as like it could be negatives and positive numbers is kind of how I think about it. And then it's even, so it has to be like things that either are 0, 2, 4, 8, like all of that are even numbers. But also the numbers that end in those, like 20 ends in a 0, so it's also an even number. Or like 28 ends in 8, so it's an even number. Those. Like the 2, 4, 6, 8, who do we appreciate? That kind of thing. So then we want to have, it's an even integer that's greater than 1. So it could be like 2 or any of the even integers that are greater than that. So it could be 2 or like 4, or it could be 6. Like all of that like basically works. Anything that keeps going forever and ever and ever. So then we have p plus 1 cannot be. That's important. We're not looking for what it can be. We're looking for what it cannot be. So all of these numbers, like 2 plus 1 is 3, 4 plus 1 is 4. Like if we keep going, 6 plus 1 is 7. All of those are going to be positive. So I would probably look first to see, like, is there a negative there that they're saying right away? Like, but there isn't, unfortunately. And then I would see, can I identify a pattern in like all of these numbers I'm testing? So like 2 plus 1, that's 3. 4 plus 1, that's 5. 6 plus 1, that's 7. So I see that they're all odd numbers, so I'm going to cross that off. I see that they're all positive, like that's a trend that I'm noticing. I'm looking for what it cannot be. Rational numbers, the way to remember this is that it's going to be like, I remember rational and ratio, like rational numbers you can make a ratio out of, which is another way to say fraction. Like we could technically make a fraction out of all these, like we could say over 1. So these are all rational, so I wouldn't pick that. And then we would say we have prime and we have even numbers. So these are all odd numbers. They're not in any even numbers, so it would have to be that one. And like while these are all prime, if you kept going, like if you got to 8, 8 plus 1 is going to be 9. That's not a prime number. So like you could have kept going to like see that this is not prime as well. So basically you're just picking numbers that fit the rules, plugging it in for p plus 1 and seeing what it cannot be. So then for number 57, we're going to go and do this one. It says, how many real solutions are there for the function f shown above? How long do lives last? This one we're going to the end of the diagnostic because I want to film this whole thing to upload today. So we're going, this is the diagnostic test is 83 questions. So then for number 57, we have this. How many real solutions are there for the function f shown above. So to find out number of solutions, that's going to be with a quadratic, meaning something has like a little 2 as the exponent as the highest one. That's going to be using the discriminant formula, which says b squared minus 4ac is going to tell us how many solutions we have. So we're going to plug in for b, the number that's being multiplied by x, so root 3. For a, it's the number being multiplied by x squared. For c, it's the number floating on by itself, so that 8 right there. So when I plug that into the discriminant formula, I have root 3 squared minus 4 times 2 times 8. By the way, kind of off track, but be careful, because one thing that people confuse because they see that this cancels out to just positive 3 is they think that you can do that with any square roots. Like you could say root 3 times root 4 equals just 3 times 4. That's not true. Root 3 times root 4 would be equal to the square root of 3 times 4. So I wanted to clarify that really quick to like prevent you from a lot of problems later on. This just happens to be root 3 times root 3, which makes it the root of 3 times 3, which is just, you can simplify to 3. It just happens to work out that way. So then root 3 squared would be 3, so then it would be minus, and this is going to be 8 times 8, which is 64. So you don't have to figure out what it's equal to, just that it's a negative number. Like we know this is going to be a negative answer, so it's going to be less than 0, which means that there are no real solutions, so it would be A. Again, this is like one of the things in chapter 4 of my book that you memorize, like one of the rules. So then let's go to number 58 right here. It says an arcade game accepts both tokens and quarters. The cost of a token is 50 cents and a quarter is worth 25 cents. Today, the machine has collected a total of 350 tokens and quarters, and the total amount of money collected is 125. How many quarters were used? So this is going to be a systems of equations. So I'm going to call T, like tokens, how many tokens we have T and how many quarters we have Q. So I'm going to say T plus Q is going to equal to 350. I'm not from France, no, but I can read that because I took French in high school. Barely remember any of it, but okay. So anyway, plus it's not that hard to read that. But T plus Q is equal to 350, and then we're going to do the cost of a token is 50 cents, so it's going to be, if we're talking about how much it collected, that has to add up to 125. So like for the tokens, it would be 0.50 times T. And then you guys are funny in the comments. Okay, so then it's going to be 0.25 times the number of quarters. So now we have our systems of equations set up nicely, and we want to know how many quarters. So that means we're working with finding what Q is. So I want to replace T. You could do like the other method, elimination, if you want, but I'm just going to do substitution. So I'm going to say that T is equal to, if I subtract Q from each side, it would be 350 minus Q. So instead of saying T right here, I can say 350 minus Q, and then I just have one unknown variable that I can solve for. So it would be 0.50 times 350 minus Q plus 0.25 Q is equal to, that's supposed to be a Q, 125. So then I'm going to do distributive property with the 0.5. So if I do 350 times 0.5, that's going to be 175. And then it's going to be 0.5 times Q, so it's going to be 0.5Q. And then we're going to have plus 0.25Q is equal to 125. So now I have to combine my like terms here of negative 0.5 and plus 25, plus 0.25, I mean, and copy down the rest. So I'm going to have 175 minus 0.25Q is equal to 125. Subtract 175 from each side. So then I'm going to get negative 0.25Q is equal to 125 minus 175, which is minus 50. So then I'm going to divide each side by 0.25, or negative 0.25, sorry. So it's going to be negative 50 divided by negative 0.25. So that's going to equal positive 200 for Q. So it's going to be H. So then let's go to this next one right over here. So it says we have in triangle P, it's plus, hold on. Plus, why are you saying plus 25? It's plus 0.25 right here, yeah, but it's minus 0.5 over here. So when you combine it, minus 0.5 and plus 0.25 is negative 0.25. Like if you have, this is saying I have minus, maybe it's confusing because I dropped the 0, but this is the same thing as 0.50. So minus 0.50 plus 0.25 is the same thing as negative 0.25. So like when you combine those, you get negative 0.25. So it would be that right there. No, you don't you add 25 to 75? No, so you can't do that because they're not like terms. So like numbers by themselves are like terms with numbers by themselves. Like you can't add or subtract stuff if it's a number and a variable involved. So then let's go to number 59 right here. So it says in triangle PQR, PQ is equal to 3, QR is equal to 4, and PR is equal to 5. What type of triangle is triangle PQR? So this is a 3, 4, 5 triangle. If you memorize your Pythagorean triples, you would know right away that this is a right triangle, so we would pick that. Now, if you hadn't memorized your Pythagorean triples, what you could do is to figure out if it's what type of triangle it is, you take the legs, which are like the two shortest sides, you square and add them, and you see if they're equal to, greater than the other side, or less than the other side squared. So this would be 5 squared. So this would be 9 plus 16, and then this is 25, and we see that it's equal to each other. So when they're equal to each other when we do that, it's a right triangle. Right there, D. Number 60, which of the following must represent the product of two odd integers? So this one is one that a lot of people forget how we represent odd and even integers. So like odd integers, we represent with 2n plus 1. So if you're trying to find the product of two odd integers, it means you're multiplying 2n plus 1 times 2n plus 1. So what we need to do is we need to FOIL. So FOIL is the acronym for what we're multiplying. F stands for multiply the first things, 2n times 2n, that's going to be 4n squared. O stands for multiplying the outer things, 2n times 1, so plus 2n. Someone said, I remember FOIL, let's go, good. And then I stands for multiply the inner things, 1 times 2n, 2n. And then L stands for I'm multiplying the last things, 1 times 1, which is just 1. Now I'm going to combine my terms right here to get 4n, so it should be 4n squared plus 4n plus 1, so it's going to be k right there. So then let's go to number 61. It says a toy car travels at a constant rate along a straight path. The table below shows the relationship between the distance d in inches that the toy car has traveled and the time since the toy ar began moving t in seconds. Which of the following could be an equation that represents the scenario? So, and for the person that just asked, this is ACT math from my ACT math book. So then what we're going to do, but this also applies to a lot of other classes and like SAT and other different tests. So what we're going to do is I'm going to see if this is a linear equation, if it's increasing, well, it's already said constant rate, but you could check it if like it didn't tell you that each time it's going up by the same amount, like the same slope, then you would know it's linear. Also, all the options here are linear, so that indicates that I have a linear equation. So linear equation is telling me that I have y equals mx plus b. That's the format that we're used to. All they did with this is they are just saying, okay, in this case, y is going to be d, and your x is going to be t. That's all they're doing. It's the same exact format. It's just that your x's are t's and your d's are representing your y's. So if you want to, you can just say this is y and this is x if that's more helpful to you. And then you could say, okay, I have to plug it into this formula. Well, the slope, m, is equal to the change in y over the change in x. So how much is it changing each time? The change in y is going to be going up by 4. The change in x is it goes up by 1, so 4 over 1, so it's just 4. So we want the number 4 to be in front of what's representing our x, which is t. So that means that it has to be either c or d. Now we just have to figure out, is the intercept, the y-intercept, -8 or +8? So what we're going to do is we're going to say, okay, we want to know y-intercept is just what the value of y is when x is 0. So if we go this way by 1, because we're going by 1 to the right, if we go to the left by 1, and we subtract 1, we get to 0. So let's do the opposite again for the y's. So if we're going the opposite direction, it should be subtracting 4, going down by 4. So then that would give us 8. So it should be +8, so it would be D. So let's go to, let me just get water really quick. Okay, let's go to Number 62, so the least common multiple, also known as like the LCM, you might have seen that more frequently in school and stuff. So the least common multiple of 40, 50, and 80 is, so least common multiple is basically like, think of it as the timetables for each of these numbers, and then like the lowest number that each of their timetables has as an answer is the lowest common multiple. So like if you wrote out all the times tables for 40 and for 50 and for 80, the lowest number that they have in common for the answer in their times table is the least common multiple. At least that's how I think about it. So I would start with the 80 and start writing that out. So then I would say like 80, and then 80 times 2 is going to be 160, 80 times 3 is 240, 80 times 4 is going to be 320, and then 80 times 5 is going to be 400. So then I'm starting with the greatest one right there, and then now I'm going to keep going to the next greatest one, and I'm going to say, okay, I can have 50, I can have 100, and you could do this in your head too, I'm just trying to like show it for people. 150, because like times 3 is 150, times 50 times 4 is 200, 50 times 5 is going to be 250, 50 times 6, basically you're just adding 50 each time. I'm trying to keep track of how many times I'm doing it. So times 6 would be 300, but I'm going to just keep adding 50 because it doesn't really matter how many times you do it, just that like you have the same answer that you're looking for, like the same number in your times tables. So like you see how when I'm comparing the 50s timetables and the 80s timetables, the lowest number that they have in common is going to be that 400 right there. So that's the lowest common multiple between those two numbers. So now let's see if this also has a multiple of 400, because if it doesn't, then we have to keep going to find a number that all three of them have in common in their times tables. But it just so happens that 40 times 10 does equal 400, so this also has a 400 in its timetables, so that would be the lowest common multiple of 400. For someone that asked what pen, this is the Papermate Inkjoy Gel 0.7 pen. So then let's go to number 63. It says just simplify this expression. So like what I do is I try to do the radical portion first. I mean, you could do it in a different order if you want. Sorry, I wasn't paying attention. I was looking at the comments to see if like anyone had a question while I was trying to circle that, so that's why I missed it. So then I have y to the -1 and then x to the -2, y to the third, and I'm going to do the radical portion right here. So that the cube root of x to the 21. Now, when you're trying to turn this into something that doesn't have a radical, what you do is it's the base x to the power of 21 over 3, because it's like the inside exponent over what type of radical it is, which is a cube root. And that would just be 21 divided by 3 is 7. So this is really just y to the -1, x to the 7th power over x to the -2, y to the 3rd power. Now, what I also like to remember is like with negative exponents and fraction bars, you just flip where they are in the fraction bar is how I think about it. So I would put like y to the -1, just put it on the bottom and make it positive. That's how I like remember this as like a shortcut. You could also do the whole, I'm going to turn this into 1 over y if you want to and just multiply everything out, but this is just easier, I think. So I just flip the positions and make the exponents positive for any negatives exponents. And then I just say that this is x to the 7th and that this is y to the 3rd. So now I can use the product rule, which says that x squared times x to the 7th, keep the like base and add the exponents. And then we have the same thing right here, so then it's going to be y to the 4th. I'm glad that this is helping people who say they understand it better now. That's the goal. So then we have x to the 9th over y to the 4th, so that's going to be b. Okay, give me 1 second. So let's go to number, this is going to apply like this table to number 64 through 68. So the table below represents the distribution of different types of flowers found in a garden, categorized by their primary color and season of blooming. Okay, if a flower is selected at random, thanks for the likes, guys. If a flower is selected at random from the garden, what is the probability that the flower is a white flower that blooms in spring or summer? So out of all the flowers in the garden, we want a white flower that blooms in spring or summer. So we're talking about white flowers in spring or summer. So these guys, 600 and 560 is what we're talking about. What we're talking about, or what we desire, is on the top of our probability fraction bar, and then on the bottom is like everything that we're picking from in this scenario. So in this scenario, the total number that we're picking from is not going to be like just 960, just this, just that. It's all of these added up, because these 960 is how many red flowers there are, 1,140 is how many blue flowers, and how many white flowers is 1,600. We're picking from all of those, so we have to add those up. When we add all of those up, we get that it's 3,700 flowers. And then also a trick that you can remember is with OR, whenever it's talking about probability with OR, this works on like, I would say like 9 times out of 10 on like exam questions on the ACT and the SAT when they're asking about probability stuff. Whenever it's an OR, it's plussing the stuff, and whenever it's and, you're multiplying the probabilities. So like this is really just 600 out of 3,700, like that you pick a spring or summer one. So like the spring one would be 600 over 3,700, and then the what's it called, the summer one would be 560 out of 3,700. If they said and, then you would be multiplying in the middle. That's like a little trick to remember. It doesn't always work, but on most of them it does. So then, especially on like the ones that you'll do on the test, like in my probability chapter, that's not going to work for all of them, because like the whole point of this book is that it's also preparing you to get like a 36 if you want to. But on most of the exams when they ask that trick's going to work. So then what we're going to do is we're just going to add this right up over here. And that's going to, and then we have to turn it into a decimal. So all we're doing is adding and dividing by 3,700, and that's going to be 0.314. So that's going to be closest to G right there. So then we're going to go to number 65. Hold on one second, guys. I'm trying to block 2 people really quick. Okay, let's keep going. So OR is adding and is multiplying. Yeah, especially if you're really bad at probability, just remember that rule, and that should get you through most of the problems like that'll end up showing up with this on the exam. Usually it's like simpler probabilities, but that won't always work. Just be aware of that. Like if you're striving for a 36 or a 1600, that's not going to always work, but this is something that'll work for people that really struggle with probabilities. This is going to help you most of the time. You don't have to show, the reason I'm not showing how I change it into a decimal is because this is ACT and you get a calculator. If you want to see how you do decimal operations, look at my YouTube for my video on the basic review videos. So then number 65 says, if a flower is selected at random from the garden, what is the probability that the flower blooms in summer? So this is not one of the or and problems, so it's just a regular probability thing. So we're going to do probability that a flower blooms in the summer. So summer, a flower blooming in the summer could be the 380, the 360, or the 560. So we can add all of those up for the desired stuff that we want, that they're asking about. In the question, they're asking about the summer flowers. So it'd be 380 plus 360 plus 560 out of the total amount of flowers that we're selecting from, which we already figured out earlier was 3,700. And then all you're going to do is you're going to add this all up and divide by 3,700. And then we're going to get that that's 0.351. And that's going to be D right there. So let's keep going to the next problem. And let me actually fold this so we can look at like the numbers while we do the next problem. So thank you for liking and sharing the live, guys. Remember, if you want to support my channel and you want to do it completely for free, if you have a Kindle Unlimited membership, you can download one of my books, the SAT or the ACT one, when it comes out in a couple days. And if you like it and this content, because this is from the book, then please leave a review. So then what we're going to do is, I'm going to leave that right there. It says, what is the probability that a flower that blooms in spring chosen at random is a white flower? Now, this is a little bit different. The population of flowers that we're picking from is not all the flowers. It's not the 3,700. It's a flower that blooms in spring. So we're only talking about the spring blooming flowers. So 320 plus 480 plus 600 is what we're talking about. So 320 plus 480 plus 600 should be the population we're talking about on the bottom, because we're picking out of just spring flowers. And we want to know the probability that it's going to be a white flower. So a white spring flower would be 600. So 600 out of the total amount of spring flowers that we have as options. So then this would just be H right there. So now let's go to the next one. So we're going to say how much more likely yeah, most people would have added the whole chart. You just have to be careful. I like to think of it as, I just say population. Some people don't like that word because they think like population is people, but I think that's the easiest way to think about it. Like you have to think what am I picking from? What's the population I'm picking from? The population that you're picking from overall is just spring flowers. And then what you desire is on top, the white spring flowers. So then number 67 is how much more likely is a flower blooming in autumn to be blue versus a flower blooming in summer? So here, when they're asking about like how much more likely, you're comparing probabilities. So let's talk about first that a flower blooming in autumn is blue. So the population we're picking from is the autumn flowers. So it's going to be 260 plus 300 plus 440. And that one of the autumn flowers is blue, so blue autumn flowers is going to be 300 is what we're talking about on top. So that's going to be the autumn version. And then we're going to have the other version that they're talking about for probability is going to be a blue flower blooming in summer. So we're going to have a blue flower blooming in summer is going to be, we're talking about 360 for blue in summer out of the total population of these summer flowers, which is going to be 380 plus 360 plus 560. So 380 plus 360 plus 560. So they're saying how much more likely is a flower blooming in autumn versus a flower blooming in summer. So these are the likelihoods of each, the probabilities of each. So if we want to know how much more likely one is than the other, we have to subtract these probabilities. So you would just plug this into your calculator, 300 divided by all that. Same thing over here, and subtract them. And when you do that, you're going to get 0.0231, and that's going to be closest to B, so you would pick that one. Okay, so let's go to number 68. Okay, so this is also referring to this chart. Given that the flowers in this garden are representative of the 10 million red, blue, and white flowers sold each year, approximately what number of okay, people are saying they didn't understand this one. So all I did was I found the likelihood of a blue flower in autumn. So I said blue in autumn, 300 is what we're talking about. Out of all the autumn flowers, because it's just saying it has to be a flower that bloomed in autumn that's blue. So 300 out of all the autumn flowers, and then I did the same thing for summer. So I said summer being blue is 360 out of all of the summer flowers. And then it's asking how much more likely one is than the other. So it's just asking about the difference in the probabilities, the difference in the likelihood. So difference is subtraction. So then let's keep going. So let's go to number 68. Given that the flowers in this garden are representative of the 10 million red, blue, and white flowers sold each year, approximately what number of flowers would be expected to be blue flowers that bloom in spring? So we want blue flowers that bloom in, oh wait, hold on. The whole point of this is I'm supposed to be making sure that like my key is completely correct for like the third round of edits. So hold on, let me just check that those two were good to go. Yes, that's good. Okay. So then let's go to number 68. So it says, given that the flowers in this garden are representative of 10 million red, blue, and white flowers sold each year, approximately what number of flowers would be expected to be blue flowers that bloom in spring? So we want blue flowers that bloom in spring. So we're talking about blue flowers in spring. 480 is what we're desiring, what we're talking about. Out of the total population of flowers, because they're talking about like out of all the flowers. So it's going to be 3,700, because earlier we remembered that like when we totaled all the flowers up, it was 3,700. That's how I got that. So then we're going to multiply that probability times the actual like population that we're supposed to be making a prediction about, which is 10 million. So when you want to find like the expected value of something, it's like the probability times whatever the larger population is that you're predicting about. So it's just going to be that, and that would be like 1,297,297.297, and that's going to be closest to 1.3 million, so it would be H. Do I teach GED math? Not on this channel, because I'm trying to like niche it down to like SAT and ACT for right now, but I do in general, yes, and a lot of this math will help you with the GED. Let me just get water really quick. Okay, so let's go to number 69. For people that want me to go back, you can see this on my YouTube channel later. So let's go to number 69. For Jennifer's graduation, her parents will pay $40 for, did you multiply the blue spring flowers? Yeah. Okay, there's a couple people confused. So all I did was I found blue spring flowers. So blue spring flowers, 480 out of the total amount of flowers. And then I multiplied that by the total amount of flowers that they want me to guess about. So like the likelihood that I have a blue spring flower based on this data is this. This is the probability. If I multiply that probability by what I need to predict about, which is this total $10 million population, that's how I figure out what the expected number should be. So then let's go to number 69. So number 69 says, for Jennifer's graduation party, her parents will pay $40 for the decorations plus $20 per person for food expenses at most. This is for the ACT, for people asking. This is ACT math. For Jennifer's graduation, her parents will pay $40 for the decorations plus $20 per person for food expenses. At most, they will spend $500 for her entire graduation party. Which of the following inequalities could be used to find the maximum number of people, X, who can attend the graduation party? So it's $20 for every X person, so 20X is going to be part of that, like $20 for every X person you invite, plus the $40 like one-time fee or expense, I guess, for decorations. It's a terrible plus sign, but it's supposed to be a plus sign. And they said that they're going to spend, they will spend at most $500. So they could spend $500, they could spend $499, $498, all of that. So it's going to be less than or equal to $500, because it could be $500 or it could be less. So it's going to be E. Okay, I'm glad that you guys are enjoying this live. Remember, follow for more. I do these lives all the time. And if you want to support me, my book is available for free on Kindle Unlimited. And if you like it, please leave a nice review, because it just came out and it needs reviews. So then let's go to number 70. The expression, this right here, is equivalent to, so you can look at the answer choices to, it's available on Kindle Unlimited for free, yes. If you have a Kindle Unlimited membership, it's available for free. Also, you can get a free 30-day trial of Kindle Unlimited. If you just Google it, like free 30-day Kindle Unlimited trial, you should be able to find it. So yeah. So then let's go to number 70. It says that we have this right here, and we want to know what it's equivalent to. Now, one of the things with these equivalent expression problems is look at the answer choices to see what they might have done. So like, for instance, all of these look like they just took out the greatest common factor. So I'm going to say, okay, I'm going to start with the number part, the easy part, 324, 648, and 810. What's the greatest common factor in between those? So are they all divisible by 324? Let's see. So I don't think 810 is, but let's see. 810, does 324 go into that? No, it does not go in evenly. So that means it can't be this one, because we can't take out 324 if it doesn't go in evenly to all of the numbers. So that means it has to be 162 as the greatest common factor. Now that I know I have to take out 162 as my greatest common factor, I can work a lot more easily with figuring out what the rest of the problem should be. So 162 is going to be the number I take out. Now what I like to do is I go by variable. So I'm going to look at the x's to see what the greatest common factor is. So x to the 9th, x to the 3rd, x to the 7th. The greatest I could take out is x to the 3rd. And then that would have to leave like the other stuff for the x's on the inside. And then if I look at the y's in each of the scenarios, the greatest y that I could take out for all of these would be y to the 3rd power, because that's the greatest one that they have in common as a factor. And then for the z's, the greatest common factor I could take out is z squared. And then you're left with everything else inside the parentheses. So right away, I know that it has to be either h or j right there. Now I just need to determine what goes inside the parentheses to determine is it h or is it j. So I know 2 times 162 is going to get me to 324, so there has to be a 2 left over inside here. You can also think about it as like you divide by what you took out, if that's easier for you. So then there's going to be a 2 in here. When you took out x cubed, what's left on the inside? Well, there's going to be an x to the 6th left on the inside. And then when you took out y cubed, what's going to be left on the inside? Well, there's going to be a y cubed left on the inside. And then when you took out z squared from z cubed, there's just a z left on the inside. And you could also check this by multiplying to make sure that you get back to this original term as well, is another thing you could do. So now I can check this against my answer choices, and I don't even have to keep going because I can already see that the only one that matches would be j. So it has to be j. Why 162? Because that's the greatest common factor, the greater number that each of these are evenly divisible by. So then let's go to number 71. So what is the equation of the line passing through the point negative 4, 3 and negative 5, 5.2? So equation of a line is just y is equal to mx plus b. And to fill out this equation, you need to find out what m and b are. Sometimes you only need to find one if it's like multiple choice. So let's start with finding what m is, the slope. So slope, the formula for slope is if you have 2 points, it's just y2 minus y1 over x2 minus x1. And you could just label these points. This I'm going to just say is x1, this will be y1, this will be x2, this will be y2. You could do it the other way around. Like you could say this is x2, y2, this is x1, y1 if you want. As long as the 1s stay together and the 2s stay together, that's what's important. So then to figure out what the slope is, I'm going to start plugging into this formula. So y2 I said was 5.2 minus what y1 is. So y1 is going to be 3. And on the bottom I have x2 is going to be negative 6 minus whatever x1 is. So x1 is negative 4. So I have to put negative 4 right there. Remember, minus and minus is a plus, so this is really just saying plus. So now I'm just going to put this into my calculator. So 5.2 minus 3 divided by, that's going to be negative 2. So then that's just going to be negative 1.1 as my slope. So negative 1.1 has to be the number that's being multiplied by x. The only one that has that as a possibility is a. Now, if there were two options that had the negative 1.1, like let's say this was negative 1.1 and you had to determine like which of these was correct, what you would do next is plugging in either one of these points, whichever you want, for x and y and solving for b. Because now you have m, it's negative 1.1, and you have x and y as one of these, as the coordinates of one of these points. So then let's go to number 72. So for number 72, it says, which of the following is equivalent to this expression right here? Okay, so let's see. So let's multiply, or not multiply, well, technically multiplying the powers, like it's power to a power rule right there. So this would be x times x to the 4th, which is just going to be x to the 5th, plus, and actually, hold on, we might not even have to do that. Hold on, I think I see group factoring that I can do easily. So let me save myself some time. I'm going to try doing that. This is just minus x times x times x is minus x cubed. Okay, so I'm going to say this is minus x cubed instead of all of that. Yeah, because then I could take out an x squared, I think would help. Yeah, if I take out an x squared, I do kind of, I'm going to still multiply that because it's easier to see that way. So I'm going to multiply all this. So x to the 2nd power squared, power to a power is going to be x to the 4th times x is going to be x to the 5th, plus 2x squared minus x cubed minus 2, all over that stuff on the bottom, which is just x to the 4th plus 2x plus x cubed plus 2. So whenever I see 4 terms together, usually I'm thinking group factoring, meaning with group factoring, what you're trying to do is like you group them into 2 separate sets of things, and you're trying to get the same factor in each of your groups that you separate them into. So like for instance, this is a group, x to the 5th plus 2x squared. I'm going to take out the greatest common factor of x squared. And then what's left on the inside? Well, on the inside, that would leave me with the x to the 5th. I would have x cubed left over. And then it would have I would have plus 2 for the 2x squared when I take out the x squared left over there. So then what I would do over here is I want to try to make the stuff in parentheses be the same on this, for this group right here with the negative x cubed minus 2. So I have to think, what can I take out so that in my parentheses as a factor, I have x cubed plus 2. What could I take out to do that? Well, if I just take out a negative 1, that works because negative 1 times x cubed is negative x cubed. Negative 1 times 2 is negative 2. Now I've reached my goal with group factoring, which is to have the same factor in parentheses. And what you can do then is you put that same factor in parentheses times the stuff on the outside. So the stuff on the outside is x squared minus 1 times x cubed plus 2 is the stuff that matches in the parentheses. So then we would put that over, and now we're going to try to do the same thing with this over here. So I'm going to group this and this. I think that would work, yeah. Sometimes you have to like rearrange them and like put other stuff near each other, but I think it would work in this case like this. So then if I take out an x there, I get x cubed plus 2. And then over here, I want to get that same thing in parentheses, x cubed plus 2. Now, I could just say that that's plus 1 because 1 times anything is just like that same thing. So now, when I do this on the bottom, I can say that the stuff on the outside is x plus 1. And the stuff on the inside that matches is x cubed plus 2. That allows me to cross out this on top and bottom, so then I'm just left with x squared minus 1 over x plus 1. So now I have to ask myself, can I factor this any further? Well, I can. X squared minus 1 is the same thing as x plus 1, x minus 1. And that's going to be over x plus 1. So I'm going to cancel out one of these on top for every one on bottom, so I'm just left with x minus 1. So it would be f. So then let's keep going to the next one. Someone said something about subtraction signs. Hold on, did I miss a subtraction sign? Let me check against the key just to make sure. I think I did it fine. 72 is supposed to be f. Yeah, I did it fine. Can you show us how we find the b way you said a few seconds ago? I'm confused. What do you mean the b way? How did you simplify it? So the numerator, so I don't know what the b way is. I'm going to answer all you guys' questions. Sorry, I'm trying to get to all of them. So I simplified it to x minus 1 because x plus 1 over x plus 1, those each cancel out. Like 1 on top and 1 on bottom cancel out. Like if you have the same thing on top and bottom, you can cancel that out. So that's how I canceled it out and simplified it. So then, where can I get your book? This one, the ACT one, let me check if it's been approved by Amazon yet. Hold on. This one's the ACT one it hasn't been approved yet, but it'll be approved in like the next day or two on Amazon. So you can get it there. I'll put a link in my bio also to like that one on my website when it comes out, like a link that says buy my book, like I have for the SAT one. If you want the SAT one, that's already out. It's on Kindle Unlimited and available in paperback on Amazon, and it's linked, my website's linked to my profile, and on the homepage of my website, like one of the first buttons is like buy my book, and then it links to it. B and y equals mx plus b. Oh, someone was saying they mean in the previous question. Okay, got it. So with this one, what I was saying is you got lucky this time because only one of them had negative 1.1 as the slope. But if you weren't lucky, and let's say that this was negative 1.1, because I just changed it to like play devil's advocate. Let's say that this is negative 1.1 as the slope. What you would do is just plug in one of the points. You can pick either one. So like, let's just pick this one because it's not a decimal. It's easier to work with. All you would do is say 3 is my y. Negative 4 is my x, and then you could do it here or here, whichever one, and like see what b is. So if you wanted to do it the basic algebra way, you could just plug in 3 for y, negative 4 for x. We already found out that negative 1.1 is m, and then you would just solve for b. So you would say this basically. 3 is equal to negative 1.1 times negative 4 plus b. So then you would just like multiply this, and then you would subtract it from each side to find out what b is, this number right here. Or you could just plug this in and see if it works. Like if you plug in negative 4 for x and 3 for y, do you get what you're supposed to get? Okay, so okay, hold on. Tutor talk, yeah. What math is this? This is ACT math. Can you re-explain the current problem we are on? So this you can see again on my YouTube channel. All I did was group factoring, and then I canceled out the factors that matched on top and bottom. So then thank you guys for liking the live. Give me 1 second to just get some water. Okay. So number 73 says, given that the strength of the gravitational pull is, the x to the 5th Why is it 5 if 4 times 1 is 1? Okay, so this part right here you're asking about. So x times x to the second power, that's going to be the power to the power rule. That's x to the 4th. But this is not power to a power rule now. Power to a power rule only applies to this one, where you multiply the powers to get 4. This is now the product rule, where this is just technically x to the 1 power and x to the 4th. When you're multiplying, you have to add the exponents. So it's going to be x to the 5th. So then let's go to number 73. Given that the strength of gravitational pull is inversely proportional to the square of the distance between two objects, if the gravitational pull is 100 units when two objects are 20 units apart, then how strong is the gravitational pull when two objects are 40 units apart? So this is going to be the inversely proportional formula thing, which just says y is equal to k over x. So what you have to do is just make sure you're consistent with what your units are for y and x, like what y and x are representing. So for instance, let's say that y is going to be the pull and the x is going to be how far apart they are. And we just have to make sure that that stays consistent. Whoopsies, I forgot to square it. So it said the square. I skipped over that word, sorry, in my head. Okay, so then it's going to be proportional to the square. So the regular inverse formula is going to be y over kx, but it said it's not just the regular one, it's over the x squared. Like it has to be inversely proportional with the square, like it's x squared. So it would be the same thing, it's just I forgot to put the little 2 there. So then it would just be y is equal to k over x squared. So then y in this case would be 100 still, and then that's going to be equal to k over x squared would be, that's 20 squared. So then it's going to be 20 squared times 100 instead. So then when you do that, you're going to get that k is equal to, that's going to be 40,000. And then what we're going to do now is now we plug that into our regular formula. So it's going to be y is equal to k, which is, 40,000, over x squared. And in this case, gravitational pull is what we're looking for. So we're looking for y when x is 40. So then you're just going to put y is equal to 40,000 divided by 40 squared. So then what we're going to do, we just punch that into our calculator, and that's going to equal 25. So it would be B. So then let's go to number 74. So for number 74, it says, thanks for liking and sharing the live, guys. Which of the following systems of inequalities matches the graph below? So let's see. So this one, when it has a dotted line for inequalities, that's matching up with these types of symbols, inequality symbols. So like the dotted line is the one without the little line underneath. The one with the line underneath matches up with the solid line. So we would look at these each individually as like their own line. So for instance, let's start with the dotted line. I would just treat that like it's a regular line that's been graphed. And I would say, okay, which of these matches up with how this is being graphed, how this line is being graphed right here. So let's see, if I rearrange this, I'm going to rearrange like the answer choices to look more like the formula that we're used to for like y equals mx plus b, but just with an inequality symbol. So what I'm going to do is I'm going to add y to each side, and I'm going to subtract 1 from each side. So then that's going to be 3x minus 1 is greater than y, which if you want to rewrite it with like people like the y on the left sometimes, so y is less than 3x minus 1 is the same thing, it's just rewriting it with y on the left. So this is saying that we have the line 3x minus 1, like just like we would have it regularly. Like think y equals 3x minus 1, how would we graph that? It's basically the same thing, except we just have to be aware that the part we're shading is going to be underneath that line. So that's what the difference is with the inequality symbols, and it tells you if it's dotted or solid. So let's see. So that's going to be greater than 1. So let's see, does that match? That has a positive slope, so that matches. And it's also going through, it looks like -1 as the y-intercept, but it's not shading below the line because y has to be less, so we have to shade down here. So it can't be f. So then these all look pretty much the same. Let's see which one's exactly the same. H has the same thing where it's 3x minus y, so we're looking at the same line, but they're saying that, and they're saying it would be the exact same thing, so we can cross that out. because it follows the exact same thing. If we add y to each side and subtract 1 from each side, it's going to be the exact same equation, so it can't be h either. So now we see that g and j are the same. So g and j are the same except they flip the inequality sign. So basically it's the same exact thing but with a different inequality symbol. So it's still going to be like for g and j, they're going to be 3x minus 1, but instead of saying that y is less than, y is going to be greater than when we manipulate it and move it all around. So this is saying y is greater than, so that means we have the right line, the 3x minus 1 that we wanted, but it has to shade above, which both of those track. So then what we're going to do is we're going to say for the next part, we're going to look at the solid line right here. So 2x plus 3y is less than or equal to 6 or greater than or equal to 6. So again, you're going to try to manipulate the stuff in the equation to get the y by itself. I'm going to do it up here so I have more room. So 2x plus 3y, the answer choice in G, it looks like this. This is the answer choice for G. I'm just rewriting it up here to get y by itself so that it looks more like y equals mx plus b. So now I'm going to say 3y is less than or equal to 6 minus 2x because I just subtract 2x from each side. I'm trying to get y by itself. Now I'm going to divide by 3 on each side. So then that's going to be 2 minus 2/3 x. So I have a negative slope and I have a positive y-intercept of 2. So I have to look and see, okay, is this a negative slope? Yes, it is. And do I have a positive 2 as my y-intercept? That could be positive 2. It could be. And now I just have to look now to see where should I shade. So the line is correct. I have to check the shading now. So this says that y has to be less than or equal to this line, basically. So it should be shading underneath for this one. This is shading above, so it can't be that one. It has to be the other inequality symbol, the flipped one, which would be j. So then let's go to the next one, number 75. Sarah has won 6 spelling bees out of 15 spelling bees. At this rate, how many spelling bees should she expect to win for the entire semester if there are 20 spelling bees left in the semester? So 6 of them she's won out of the 15 spelling bees. And that has to be directly proportional with her, with the amount that she's going to win. So like wins go on top and match on top. And on the bottom, it's going to be the entire amount of spelling bees in the semester, which is going to be just 15 plus the 20 that are left. Because there's 15 that have already occurred plus the 20 that are left. So then that's just going to be 6 over 15 is equal to x over 35. We're going to cross multiply and solve for x. So this is going to be 6 times 35 is equal to 15x. So then just divide by 15 on each side to get x by itself. And that's going to give you that x is equal to 14. So it would be E. Okay, so let's go now to, let me just move this and let me check something really quick to make sure I have all the right stuff. Yes, we're good on that. Okay, no edits needed. So let's go to number 76. Which of the following could be the value of x in this equation? So right here, let's see. I would just think, okay, I have to, well, is there an easy way to do this? I would just automatically think cross multiplication. But you could also, oh, hold on, you could factor this out. You could say that the greatest common factor on top would be x, like you can take an x out, and then it's left with x minus 3 inside the parentheses over x minus 3, and that has to equal negative 3, because then you can cross these out and find that x equals negative 3 is equal to negative 3. And then also, some people might have said, like, said that it was 3 also. If you multiply this all out, you have to be careful because 3 can't be possible because the denominator would then equal 0, which is impossible. So like you could have also seen that automatically and crossed out that it was g or h because it can never have a 0 as a denominator. So it would be f. Are you doing anything related to English? No, not right now, no. So I'm trying to like promote my book and stuff. So like this is my math book. I'm working on an English book and a reading book, but those are nowhere near done yet. So then let's go to, hold on, let me get water really quick. And check that this is all good. Yep. Okay, so let's go to 77 right now. So we have a is equal to p times 1 plus r to the t power. And then the amount A that a house is worth over T years is shown in the equation above. P is the initial price and R is the annual rate of growth. Which of the following choices, or which of the choices below represents R in terms of the other variables? So we were trying to get R by itself. So to do that, we have to move everything else away from R. We're going to first start by moving P away. So we're going to divide by P on each side. That gives us A over P is equal to 1 plus R to the T power. Then we have to move the T. So we move the T by doing the opposite operation. So just like if we were squaring something, like we have x squared is equal to 4, or actually let's do cubing because it's easier to see with like a bigger number. So x cubed is equal to 4. How we would get x by itself is we cube root each side. So you would take the cube root of 4. You're going to take the t root of the other side. That's the opposite operation. So like we don't know what number t is, so we're just taking the t root as the opposite operation to cancel it out. So then that's equal to 1 plus r. So then to get r completely by itself, we have to subtract 1 from each side. So then it's going to be this minus 1 equals r. So we're looking for that. So that's going to be C right over here. Are you planning to do C best math practice? No, sorry. I'm trying to focusing on like my niche kind of thing. So like ACT and SAT is what I've been focusing on mostly. So then let's go to number 78, but a lot of this stuff applies to other exams as well. So then let's go to this one. It says, assume 1 British pound equals $1.55. Assume 1 euro equals $1.20. Andrew took $620 and converted them to British pounds. While in Britain, he spent 88 of his British pounds and converted his remaining pounds into euros. While visiting Europe, he spent 120 euros. Upon returning to the US, he converted his remaining euros to US dollars. How many US dollars did Andrew have left over from his trip? Okay, so let's see. Let's go like part by part. So he had 620 US dollars. And then let's convert that to British pounds. So it says that $1.55 is equal to 1 British pound, which I'm going to call B as like British pounds. So if I do this, then the American dollar units cancel out, and I'm just left with how many British pounds I have on top. So all I have to do is 620 divided by 1.50, or 1.55, sorry, and then that's going to be 400 British pounds. And then it says in the scenario, now he's going to spend 88 of those, so we have to subtract 88 British pounds. So then he's going to be having, that's going to be 312 British pounds that he has now. So then now he's at 312 British pounds, and it says that he's going to convert them into euros. So in 1 British pound, there's going to be $1.55 American dollars. And then we want euros. So if we look at the relationship they gave us with euros, it's $1.20 is equal to 1 euro. So I can do $1.20 is equal to 1 euro. This cancels out B and B here. It cancels out American dollars, and I'm just left with how many euros I have. So then if I do the math over here, I would get 403, I'm going to call E euros. And then it says that he spent 120 euros, so we have to subtract 120 euros. So then that's going to give us 283 euros. And then upon returning to the US, he converted his remaining euros to US dollars. So now we have to convert this into US dollars. So 283 euros converted into US dollars. Well, we know in 1 euro, there's going to be $1.20 in US dollars. These cancel out, so then we're just left with how many US dollars it is, which would be $339.60 or $339.60. So that's going to be H right there. Thanks for the likes and shares, guys. So then we're going to go to number 79, which says, given that the average of P and Q is 16 and R is 8, R equals 8, what is the average of P, Q, and R? So let's start writing down our given scenario. So P plus Q, the average, meaning the mean, is another way to say that. P plus Q divided by 2, because average is just like you add them up and divide by how many numbers you're adding. So P plus Q divided by 2 is equal to the mean or average, 16. And then they're telling you that R is equal to 8. and they want to know the average or the mean of P plus Q plus R divided by how many there are, which is 3. What's this? What's that average? What's that mean? So we know that R is 8, but we need to figure out what P plus Q is. Well, we can figure that out from this first equation. Multiply each side by 2, and you're going to get that P plus Q is equal to 32. So we could say P plus Q is going to be 32 plus, they told us R is 8, over 3, and that's going to answer our question. So we have 40 over 3 answers our question, which is going to be equal to, that's C, 13.3. So then let's go to number 80. This is, yeah, everyone always asks about the pen. It's okay. So this is Papermate Inkjoy Gel Pen 0.7. So then let's go to number 80. A high school freshman is being assigned a new locker. He receives a lock. To use for his locker. The front office has already set the first digit in his locker combination to 7. For the 2 remaining digits in his new locker combination, he can choose from digits 0 through 9. How many locker combinations are possible? Okay, so they've already picked the first number for him, and he has 2 remaining digits that he can pick from. So that's really what we're interested in, like the possibilities for those last 2 digits. So if we're talking about 0 through 9, that could be 0, that could be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's like 10 different possibilities for digits in one of those places. And then he has another 10 possibilities. So then we would multiply those together, and that's just the same thing as 10 squared. So it would be J. So then let's look at number 81. It says for 81, Emma is trying to gather data on public sentiment towards a new swimming pool in her county. Emma decides to ask her classmates about their thoughts on the idea during school. Which of the following could improve Emma's approach? 1, Emma could ask her dad to ask his colleagues at work about their opinion. Okay, so let's think. So that would be at work, asking about their opinion. Well, it says in the county is where she's interested in. We don't necessarily know that, like, some people travel a lot for work, like outside of where their county is. So that might be the wrong population to be asking if she wants to know how people in her county feel about the swimming pool. So I would say that's a bad option. And then number 2 says Emma could enlist some of her friends to help collect data at school. Now, you go to the school in the county that you live in, so that would be like the population she's interested in, so that matches. So that's okay. And then Emma could do the same thing at the local park. Again, like a local park is going to be in the same county, so that's like the people that you're interested in surveying and figuring out what they feel about this new pool. So it's going to be 2 and 3, so it's going to be C. So let's go to 82. So it says for 82, 15 employees attended a professional development course, and their average score for the final assessment was 76. Unfortunately, Sally was on vacation during the course. When she returned and took the course, the average score for the final assessment decreased to 73. What was Sally's score? So let's talk about the first scenario, that their average score, meaning their mean score, was 76. And that was for the 15 employees. So we're going to say the sum of those 15 employees' test scores divided by 15 employees has to equal the mean of 76. So if we multiply each side, thank you guys for sharing the live, and then so we're going to multiply each side by 15 to find out what the sum of 15 is. So then when we do that, we get that the sum of 15 is equal to 1,140. And then this is going to help us figure out the answer to our question, which is what is Sally's score. So if the new mean or the new average is going to be 73, and we use the mean equation, we would say that the sum of everybody's scores, all 16 employees, has to be the sum of 15 plus, we'll call Sally's score X, divided by the 16 employees. Now we figured out what sum of 15 is, so we could just plug that in and then solve for X. So then it's going to be 73 is equal to 1,140 plus X divided by 16. So we're just going to multiply each side by 16. So that's going to give you 73 times 16 is 1,168 is equal to 1,140 plus X. So then you're just going to subtract 1,140 from each side. It's going to cancel out there. And then over here, you're just going to be left with, that's going to be 28. So 28 is equal to x, so it's going to be G. Thanks for the likes, guys. So let's keep going. Let's go to number 83. This is the last question on the diagnostic test. So then let's go to, this one says, based on the table below, which of the following products is not possible? Assume M, P, and Q are positive integers. So these are matrices. So with matrices, you have to do the the rows times the columns is how did you get 1,168? I just multiplied each side by 16. So 16 times 16 on this side would cancel out. So then it's 73 times 16 is that. So then with matrices, you have to do rows. I shouldn't have written that there because now I'm going to need that space. Hold on. Rows times columns is how you have to think about it. So like the number of rows times the number of columns. So if we're talking about AB, like A would be Q times P, because that's Q rows times P columns. And then if you were to write it out in this notation for B, it would be the rows times the columns is going to be P times Q. Now the reason you have to do this is because this tells you if you can multiply them. So we're looking for what's not possible. It is possible if the inside numbers, or in this case letters, variables, are the same thing, they cancel out, then it's possible to do the multiplication. If they don't cancel out, if they're not the same thing, it's not possible. So we're looking for what's not possible. This is possible because the middle parts cancel out, so it won't be that one. Now let's do AC. So we already know A is rows, Q times P, columns. Now let's do C. C is going to be P rows times M columns. The middle cancels out, so you can do that. Now let's do AD. So AD is going to be Q times P, because Q rows times P columns. And then let's do for D, it's going to be P times P. So these cancel out. Remember, it's just rows times columns. So then it's not going to be that one. Whoops. So then we're going to go to D. So D is going to be C, which is rows times columns would be P times M. And then A, again, is just rows times columns, which would be Q times P. Now these are not the same thing. Those don't cancel out. So it would have to be D.